for something more, for too many years now. Working hard to find the will inside, lift me up out of the bed. Turn down restaurants, I don't have time. Turn down the restaurants. Rosy water, heart soaking in my skin, on your skin. We could both be a little more forgiving of everything. It's something, all nothing. Silence threatens to pay the rent. I think a lot of it at night. Somewhere
face. Finally, my nearsight became corrected. Join the collective, we could become each other and discover the relationship from the other's perspective. I know you regret that you could have expected I will forget, but I promise I won't if it happens again. I guess I'll die here alone. I guess I'll die here alone. Tripped out under air mattress deep, flame my soul into madness. Bless the ground, just tell me where I'm supposed to go now. She looked around and said, I'm sorry, babe, I don't know. Gotta find the other's perspective. I know you regret that you could expect I will forget, but I promise I won't if it happens again. I guess I'll die here alone. I guess I'll die here alone. I guess I'll die alone. Sake by the light.
Bring a nice bottle of wine, have a holiday. 'Cause baby, summertime's around the corner. And maybe this time I'll get to know you. Everyone's going out on a summer night. inside your head. Been thinking on you only. Words that should be said in the summer rain. Don't be late. Summer child.
because I don't like him. He can go fuck himself.
Fuck life, let's dance. I don't care what Tony's haters think of me.
Whatever.
Let's leave for hands, they hate we dance. I don't care what they think of me. I couldn't care less about you. Talk behind my back. She says I'm a one-right rental. I don't give a fuck. She said, honey, money, all that I need. No lovey-dovey, sweet shit, no calling. Toxic lawsuit, she said I'm grabbing every fucking penny that you
He
got.
can go fuck himself.
I couldn't care less about you. Talk behind my back. She says I'm a one-right rental. I don't give a fuck. It started as a thing we did for fun, and that's when all the feelings had begun. And I know that I'm selfish with my love, but baby, I can tell you're not the one. I gotta delete you, baby. I wanna delete you, baby. It wasn't something you were searching for, but rather something you were looking forward to. Been thinking about this choice each night and day. I hope you don't get mad when I'm about to say that I gotta delete you, baby. I wanna delete you,
Are you sure you want to delete? Okay, deleting now.
Okay, welcome everybody. We're going to get it started in just a moment, so if you guys would find your seats. I guess I don't have a way to test necessarily that the other rooms, they're hearing good. Maybe we could see through the windows. Hopefully you guys are hearing me in the other rooms pretty well. The way maybe Cody went over this as you guys came in today, the way that it's going to be structured is we're streaming live from one room, and then the other two rooms will hear in the audio. We are going to be using Discord throughout the event to kind of coordinate you guys and be able to like work through a whole bunch of different activities. So there's just a couple things like getting set up for you guys to know. So this is like your to-do list. One, to make sure to join the Discord. If you do join the Discord, we're going to have like basically a emoji on the ChainShot bot where you can click on it and it'll open up the channel for you for Web3 EXP. I'll show you what that looks like. Let me pull it on over. So if you come over here into the Discord, once you've joined, you should be able to download Discord, or you can actually use the web app as well, whichever works better for you. Maybe here it might be easier just to jump on the web app or jump on the browser app. But if you come in here, you can go into choose channel, and there's going to be a message here that the chain bot is going to ask you to click on the to-do link, and that's going to open up a bunch of channels for you for Web3 EXP. So make sure that you guys are on there. I'll bring this up again a little bit later as more people start to come in, and we'll make sure that you guys are all set up. I kind of expect the first hour of this event to be pretty heavy in the administrative side, making sure that you guys are like well set up and that we can get on the activities together. Something that might be a little bit fun to kind of kick this event off is to get you guys to know your team. So you guys will notice that on your table there, you are on a specific team. Now that table is not the only table that has that emoji. You also have a couple other tables that are close to you that are also on your team. So there should be a total of 10 teams across the 3 rooms. So let's kick it off with maybe the people that are on Team Unicorn. Would you guys want to raise your hands and take a look around the room, see if you're on Team Unicorn? So people in my room are looking at me puzzled right now. There is no Team Unicorn in my room. It's going to be in one of the other rooms. Hopefully you guys raise your hands. I'm just going to believe you. But there you go, Team Unicorn. Fun fact, Team Unicorn is the only one that has a horizontal page. That was a feature, maybe not a bug. I don't know. I messed up the printing there. So we also have Team Castle. Team Castle want to raise their hands? I also think that's not in my room. Take a look around, see who's on your table. There should be the tables that are close to you. These are going to be the people that you're going to be working together with. So when it comes to the capture the flag challenges, you guys are going to be working together, and we're going to score you based on how well your team does. So you guys will be able to work on these challenges. They're going to be quite difficult. So I think putting your heads together is going to be something that's going to be really, really helpful. So then the next up, we have Team Cheese. Team Cheese, if you want to raise your hands. Take a look around. Okay. And then we have Team Rocket. It's like a Pokemon reference or something. We got Team Bicycle. I know that's in my room. There we go. Cool, that's all you guys. We got Team Ghost. Sweet, there's the Team Ghost. We got Team Sailboat. There they are in the back. We got Team Coffee. Team Mushroom. Good choice. And Team Pancakes. Cool. Okay, awesome. All right, so when you guys come in here, what you're going to see is once you have clicked on this ta-da emoji, you're going to be into the different ChainShot channels. What you could do to unlock your specific team's channel is click on the emoji inside of that choose channel as well. So make sure to go to your team. I see Team Coffee's in the lead for the most people that have clicked on it, so they're getting off to a good start. Mushroom's right behind. But make sure to, Mushroom saw that it was competition and they raised the stakes. So you can see what that's going to do is it's going to unlock one of these channels for you. You can message your team in here instead of messaging out loud or talking, as we like to call it. You can message on Discord if you want to like maybe keep it secret what you're trying to say. Like if you guys are trying to capture the flag and you have an idea of how to do it and you need somebody else's help, you could message on here. We're also going to be sending messages to you guys that are going to be specific to your team through this Discord. So make sure to unlock those, and that's going to be really, really helpful throughout the event. And I can see some people already messaging in there. So super cool. Okay, so that's the first piece of administrative side here. We're going to keep working with you guys on the administrative side. So if you don't have the Discord invite, we'll come around and make sure that you get it. It's just discord.gg/chainshot. So if you just type that into a web browser, it should bring you up with a chainshot invite to make sure that you're inside of the Discord. The other thing that's going to be a little bit tricky is to make sure that you're all enrolled in the Web3 EXP course on chainshot. I know that there's a couple people here that I think are going to have a little bit of a tricky thing with that, but if you see anybody in an orange sweater, which is only just a couple of us, we can get you set up inside of Web3 EXP, so just let us know and we'll make sure that you're enrolled in there. Where you'll see that is like if you go to chainshot.com, I'm inside of the browser here. If you go to chainshot.com, you'll be enrolled in the Web3 EXP course. And this is just going to give you access to all the exercises we are going to do today. So if you don't see it, you might have to click down and then kind of pull up your course here. So Web3 EXP will be the course that we're going to be running through today. So let us know if you guys have any problems with that, like during the activity time or during the break, and we'll get you hooked up in there. And the last thing is to make sure to download an IDE. So we recommend just using VS Code because that's what I'm going to be using. So like, you know, it'll be easiest to kind of just look up and see what I'm doing and kind of just follow along with that. So if you don't have an IDE, I would suggest doing VS Code. If you already have an IDE that you like to use, feel free to use it. That's totally fine. We have no, no hard sort of feelings on using VS Code there. So cool. So just a little bit of like introduction, like what is ChainShot? So ChainShot, we are a education team. We run a 10-week part-time Ethereum developer bootcamp. That's our main product. So this is something that's remote. It's instructor-led. We have large cohort sizes with small groups. So basically what we do is we have like something like this, a very big event, and then we will break people down into smaller groups so they can work on activities. And then we sort of teach everything from 0 to 100 in Ethereum development, working from the very basics of cryptographic fundamentals, and then working through understanding how to communicate with an Ethereum node, and then really diving deep into Solidity. So that's something that we run 4 times a year. And we actually have one coming up next week that we're starting and kicking off there. So I think there might still be some time to sign up if you guys are interested in doing that, but it is coming up real soon. So today we have 2 instructors. It's me, Dan Nolan, and then Al Lucan. He might be in your room. He might not be. He's not in my room. But you'll see him also with an orange sweater, and he's going to be, he'll be around and being helpful and also taking over in the instruction later. So a little bit about me. I co-founded ChainShot in 2018, so about 4 years ago. We've been building up the platform that you guys are really going to see today and working on all the content. And just over the last year or 2, we've done really well with the bootcamp side of things. Al Lucan is a graduate from the ChainShot bootcamp and then joined us on the team. He's so excited about the platform that we brought him on. And now he's an instructor for us as well. We also have 6 mentors here today. Their names are Massimiliano, Shane, Marco, Hao, Nico, and Stephen. For these 6 people, you will see them around in the room standing up. So maybe if you guys, you might see them in the back here as well. So maybe if you guys raise your hand, if you're a mentor, yeah, we got a few back here. We got 3. So the mentors will be around to help you guys out. And if you have any questions, like getting the different environments set up, or if you have any questions about Solidity, these are people that can help you. All of these mentors here today are actually alumni from our 10-week bootcamp. So they know this content really, really well. And we're super excited to have them with us today. So cool. Yeah, raise your hand, mentors. I guess I had a cue for that. Cool. So I think I went over all this. Discord, make sure to select your emoji. This is going to be your team for Capture the Flags. Capture the Flags, what we're going to do is if your team is the first one to capture the flag, you get 5 points. If your team is the second one, it's 3 points. And if your team is the third one, you get 1 point. We're going to have a leaderboard over the course of the event. And if you are the winning team, you will get a NFT brought to you by Mint Kudos, which is a very cool platform for NFT sort of being able to commemorate something that you did, some activity that you did. So we'll be taking a look at that at the end. And we'll be using Chainshot.com as a platform for all the coding exercises. And recommend you use VS Code or any IDE if you have one that you're particularly fond of. Cool. And the final thing, just before we get started, is a huge shout out to DevConnect. Without them, this would not be happening. I mean, DevConnect has done just such a phenomenal job of setting this all up, and the wonderful folks here, helping out with running the event. We couldn't do it without them. They do all the legwork around here. We're just here teaching, and they make our jobs really easy. So shout out to DevConnect and all the wonderful people helping setting up this venue. Cool, so let's get started. So super excited to start it off today. This is going to be, I expect that this is going to be a bit of a challenging boot camp for most people here. We kind of set it up that way. We're going to be talking about specifically call data to begin with. One of the things that we want you guys to do is take away a lot from this 2-day event. We want you guys to be able to go from this event into the hackathon this weekend, if you guys are doing that, and be able to just like completely dominate with your skills that you learned here. So that's something that we were really keyed in on. We tried to think about what is the best 2-day experience that we could possibly come up with, where the skills coming out of the 2-day bootcamp is something that you could really take away and start to do really well with the projects. So this is what we came up with. You will, for many of you, you will feel as though it's going to be a bit challenging, and we do expect it to be that way. But just, hold on. We're going to explain everything to you, and, ask us a lot of questions. We want to be really helpful, and, we'll work together to make sure that all these concepts are, something that everyone can kind of break down and understand. So we're going to start off with call data. This is going to go till 11:15. The way that today is going to work is we're going to have an hour and 15 minutes to do lecture and activities, and then we're going to do a 30-minute break. During that time, we'll send you guys some resources and stuff, so if you want to work on some stuff, you're free to, or you can get up, stretch, grab a snack, grab some water, grab some coffee, whatever you want to do during that time, that's totally up to you. And then we'll do another hour and 15 followed by an hour lunch, and then another hour and 15 followed by a 30-minute break, and another hour and 15 at the end there. So yeah, we'll go ahead and kick things off. So cool. The first thing that we're going to be talking about today is call data. So you may have heard this term before, just generally, especially now that we're talking about layer 2s a lot. You hear about call data, right? Ethereum is moving to this, being this chain where call data is just being posted by these different rollups, right? So what we wanted to start off with here is call data very blankly, and think about just how to communicate across externally owned accounts and smart contracts. So call data is the first concept that we're going to be talking about today. So when you call a function on a smart contract, the way that it actually gets encoded is you take the function, and what you do is you actually take the catch-ack hash of that, and that is going to give you the signature for that particular method that you are going to be interacting with on a smart contract, right? So the example that we have here is that you have a hello world function here that takes a uint 256. What you would do in order to be able to communicate with a smart contract, if a smart contract had a hello world function on it, you would first take the hash of hello world uint 256. This is going to give you a 256-bit value, but what you're going to do is you're going to take off the first 4 bytes, which is going to be 8 hexadecimal characters, and you are going to use that as sort of the signature to tell Solidity, hey, I'm targeting this particular function, right? So this is going to be a bit of a low-level concept, but something that's really important as you get really good into Solidity development is understanding how these things work, because certain times you really will have to get this low, right? So today we're going to kind of take a look at this on the low level, encoding call data and sending it to the smart contracts. So that's the first key piece, right? Take the smart contract function, put it into a hash, grab those first 4 bytes and say, okay, we're going to target this function. That's how we're going to try to communicate with the smart contract. And you could do that whether you are calling it from an externally owned account, which is what you typically have, right? When you have a wallet or you have a private key, you are somebody controlling an address, right, with a private key. in that case, you have what's called an externally owned account. You're going to see that shortened here as EOA in many of these slides. And EOA can communicate with a smart contract this way, where they're going to take the first 4 bytes of the hash and try to target a smart contract function. Or another smart contract could also communicate with a smart contract that way. It's going to be the same thing, right? So this is going to be referred to as like a message call, and a message call is going to have this like call data construction here that you can see below, which is we're going to take that. Now that we've targeted hello world with that first 4 bytes here, C605F76C, once we've targeted that, what we need to do is then append any arguments. For the uint 256 specifically, we're going to pad it out to 32 bytes because it's a uint 256, so it's 256 bits or 32 bytes, right? 8 bits in a byte. So then what we're going to do is we're going to take the value 5, if that's what we want to send to hello world, and we're going to end up with that, right? That's going to be our call data. So that final thing down there that's bolded, if you were trying to send to a smart contract that you want to target its function hello world in Solidity and pass the value 5, you would pass exactly this call data. That's going to be a key thing to keep in mind today. This is going to come up in the second capture of the flag today, so make sure you guys are thinking about this. I'm going to show you a bit of an example with this as well to kind of kick this off, but I don't want to spend too much time on this so you guys can jump into the activities. But let's go ahead and get started with this. I'm going to show you an example and just kind of do a little bit of live coding. So let's go ahead and bring this up. Today, we're going to be focused around Hardhat, which is a developer framework that works really, really well for smart contract development, especially if you're somebody who already knows JavaScript. If you know Ethers.js, then that's phenomenal. Then Hardhat is really good for you. If you guys really know Hardhat already, then awesome. What we're going to do is we're going to start off by just targeting a function, just like we did over here. Maybe we could use that exact hello world just to show you guys exactly how you would send call data to a method. So we can think about like, okay, this is actually the bare minimum when it comes to communicating with smart contracts, right? So I'm going to create like I have like a folder that I keep all my temporary repositories in, and I'm going to create one just called like, let's just say call data fun, right? If that's not already a folder in there. And what I'm going to do is I'm just going to start this off with a blank package.json, which is going to install all my dependencies here. And you guys are welcome to follow along with this if you want to. You don't have to necessarily work on this at the moment. We're going to definitely do some exercises around this, but you're welcome to follow along. I'll keep the instructions pretty clear. So what I'm going to do is I'm going to start off with that package.json. The first thing that I'm going to do is I'm going to install Hardhat. And looks like the internet here is quite good, so that's awesome. But maybe if we're all installing Hardhat at the same time, that might be a little tricky. So once I've installed Hardhat, what I'm going to do is I'm going to start a new Hardhat project. And this is something that I want you guys to get a little bit familiar with today. If you've never created a Hardhat project, then during the break, make sure to go through this process, because especially during the capture the flag exercises, like that's going to be your best way to actually capture the flag successfully, is just create a new Hardhat project and then try to interact with the smart contract that we already have on chain. So I'm going to go ahead and create a basic sample project. That's the one that I always choose, and then I just click all the options, yes, yes, and that's my project root. And it'll take just a moment, and when it comes up, we'll go ahead and send call data to a smart contract function, right? This is something that I'll tell you guys, like, you don't typically learn until like the tail end of your Solidity experience, but I think starting off with it is going to be something that's going to be really interesting and just make it easier for you guys to conceptualize what's actually happening behind the scenes, right? So we'll go ahead and get started with this. I have this call data fun contract folder already set up, and it's got like my Hardhat basic sample repository. Let me know if anyone in the back here can't see it. I think I have the deepest room, so I don't know if you guys, okay, I get a thumbs up. So, okay, cool. So we'll go ahead and get started on this. So we already have like this greeter project. Maybe we'll just do the hello world example that was there in the slides, right? Just to keep this simple. And we'll just have a hello world. And what we'll do is we're going to take in a uint 256, and we'll just call it x. And maybe what can we do? What we'll do is we'll just change a value on the smart contract, and we'll make it something that we can actually look up. So that's going to be the key thing here is we can actually go and look up that value. I'm actually going to put the underscore over here and then do something like this. So what I'm going to do is I'm going to have this function that we can call out to. And the main thing that I want to do is I just want to change that value x, right? So a really simple function. The thing that I'm going to do a little bit differently here than what we typically do is I'm actually just going to encode the call data and send it directly to the function. And I'm going to do that manually for you guys so we can see first how that works, and then we will get into how it's easier using something like hard hat and ethers. Okay, we have our greeter. What I'm going to do is I'm going to set up a test case. Today, we're going to do a lot of stuff with unit testing. So what I'm going to do is I'm going to set up a very simple test case. And what we're going to do is we're just going to first, I'm going to show you guys how you would typically do this if you were just trying to interact with the method and change the value, right? So if we were going to do this typically, what I would do is I really like in unit testing to do, we will go over unit testing as a separate topic. So if you've never done unit testing, we'll send you over some resources a little bit later today. But essentially the way that this works is we're going to test the smart contract. This before each is going to run before each of these tests here. So what I will do before each one is I'm going to deploy a new smart contract. My smart contract is going to be the greeter. It doesn't take any constructor arguments anymore, so I don't need this. This is going to be the basic boilerplate for deploying a smart contract here. We're going to get a contract factory, and then we're going to go ahead and deploy it. And then we can get access to it inside of our test case by having a variable that's going to be scoped to be able to do that. And what we'll do is we will first go ahead and change the value x. So, I mean, to begin with, should have x at the value 0. That's what it's going to start off with. So, I mean, my first sort of assertion that I can make here is that the value x is going to be equal to 0. So if I say greeter.x, and this is going to be asynchronous, right? So I'm going to go look up the value for x. It's going to start off at 0. And if everything's working properly, then we should see that when I go to run tests with npx hard hat test, this should actually come up with not that, because I forgot async over here. It's a common mistake. So I'll need to make sure to put async if I want to use await. And we can see that x has the value 0, right? So the next step that I want to do is I want to actually change x. I'm just going to do it inside of the same test here. So it should allow us to change x. So to change x, what we need to do is we need to say greeter.helloworld, right? That's the name of our function. We're going to pass in the value 5. And then what we expect x to be when we go to assert this is that it's going to be 5, right? So we're changing the value, then we're going and retrieving the value. It's going to be 5, and we should pass our test cases, right? So we're basically changing a value and checking that that value has actually changed inside of the smart contract. Now what I want to show you guys is a little bit more behind the scenes, right? So if some of this is unfamiliar, by the way, we will be coming around to help you guys out with hard hat and unit testing, so do let us know. But now I want to show you guys a little bit behind the scenes. I want to break this line down, this line 17 right here, into something that is a little bit more low level, right? So what's actually happening with line 17? So line 17, this right here is actually something that's being provided to us by ethers.js. So, and well, a little bit of hard hat as well. Hard hat's doing a lot of work behind the scenes here. Ethers.js specifically is taking this method right here with this argument and basically breaking it down into this final call data construction, right? Behind the scenes, it's figuring out that hello world with a uint actually goes to that specific target signature, and then the value is going to be padded on there. And then it's going to send the data over in the data field to target this function on the smart contract. So what this will actually look like if we wanted to do this ourselves is, I mean, the first thing that we could go do is we can go target this function, right? So if I'm going to target this function, what I need is the function signature, and I need to go take the catch-ack hash of it, right? So let's go ahead and do that. So I'm just going to do this online to make it a little bit more visual. It's like a catch-ack 256 online. And what we could do here is I could put in the input. Now, you have to be really careful when you are encoding signatures like this. It doesn't require that you put in the arguments, and it does require that these data types are specifically the data types that they expect. So uint is actually an alias for uint 256, but when you are actually targeting a function, you have to make sure that you put in uint 256 here. So our actual target for this function is going to be this one here. It's going to be the first 4 bytes of this function. And what this is going to do is it's going to tell Solidity, hey, this is the function that we're trying to call. We're trying to call hello world. This is the first 4 bytes. So that's actually the first part of my call data construction, which I'm going to bring back over here to my test. And here's my first part of my call data. It is the signature. Maybe I'll even label this as like signature, right? Maybe we'll put a 0x in front of there. So 0x designates that the rest of the value is going to be hexadecimal. So when we're using JavaScript strings, a lot of the times when using these with libraries, it's important to put that 0x in front so that they know they're dealing with hexadecimal. So I'm just going to put it there just in case. And then the argument is going to be, I don't know, what do we want to change x to? 42 or something? Let's just go ahead. You know what? It's going to be easiest if I just go ahead and grab from the slide the padded out values. Oh no, I kind of lost it. Sorry, guys. Let me just grab the padded out values here, right? So we're going to pad this out to 32 bytes. And so I'll just make this my argument. And maybe instead of 5, we'll just do 7, right? So we'll have our signature, we'll have our argument. To combined, these two are going to be our complete call data. So signature plus argument is the call data. And what we're going to do is we're going to go ahead and call out to the contract and send that call data along. So if I say greeter dot, so what I'm going to do is I'm going to send a transaction. What I need in order to send a transaction is somebody who's going to pay for the gas, right? This is something that you don't see here on line 24 is somebody paying for the gas, because Hardhat is actually automatically hooking you up to accounts that they generate just for this test case, right? So one thing that we will need to do is we need to get somebody who's going to pay for this gas. And we actually do get that provided through Hardhat as a signer. So what I'm going to do is I'm going to grab the first signer. In order to do that, there's a provider that's provided to us on Ethers through Hardhat Ethers. Don't worry, we'll explain a little bit more of this if some of this is unfamiliar. What we're going to do is we're going to get the first signer. So we're going to get signer 0. And this is going to be the person who's going to pay for that gas. And what we're going to do is we're going to say signer.sendTransaction. And we're going to pass in the call data here. So you can see, now this is basically as low level as we're going to get. When it comes to an Ethereum transaction, there's actually a data field that gets RLP encoded into the raw transaction. This data here is basically as low level as we're going to get today. It's a field that's actually noted by an Ethereum node and picked up there. So this is really the way that this call data is going to get encoded inside of the transaction. The transaction is also going to include things like the signature, how much gas you're willing to spend, the value if you're sending any Ether on it. And specifically, we also need to designate where we're sending this call data to. So we could send this call data to any address, but if it's not a smart contract, it's not going to respond. We want to send it to a smart contract in this case, so we're going to send it to this greeter address. So we're going to go ahead and send that transaction over. And these 6 lines of code, these 6, maybe 5, I don't know, depending on if you think that this is multiple lines, right? These lines of code right here are what's actually kind of going on behind the scenes here on 32. We could actually go more low level than this, right? But this is really what's happening behind the scenes. Like Ethers.js is actually encoding this hello world, sending 5 over, and creating call data that we are sending to a greeter address. So theoretically, we could replace this, and our test cases should still work. I'm struggling with S's today. So let's go ahead and test that out. And okay, so it gave me expected big number value 7 to equal 5. Oh, right, because I changed this to 7, right? That makes sense. See, I caught myself off there. I changed it to 7, and so the test case should actually work there. There we go. So that's exactly what's happening behind the scenes, right? We're sending call data. When you're targeting a smart contract, either from an externally owned account when you have a private key, or when you're doing it from a smart contract to another smart contract, we're sending call data, and this is how the encoding works, right, behind the scenes. That's going to be a key thing to take away, especially towards the end of the day today as we do the capture the flags. Don't worry, we're going to do a lot of exercises on this stuff, so if it's a little crazy at first, we'll dive into it a little more. So, okay, cool. So that is that. Let's see how to run from the current slide. Oh, sweet. Okay, so that is that. That's how you do call data. Now, taking a step back, there's actually a couple other ways to interact from a smart contract to another smart contract. One of the ways of doing this is using something like an interface. So an interface is made to make it easy for you to just communicate with a smart contract. If you were looking at what I just did and you were like, that's crazy, I don't want to ever encode my own call data, you don't have to in most cases, right? You'll use something like an interface or maybe another contract, and that definition will allow Solidity to actually be able to construct that call data to be able to make that message call over to another smart contract. So the interface kind of works a little like this, right? We have a smart contract, and at first, it's like, how do we communicate with another smart contract, right? Like the hello world is deployed somewhere else. We have our own smart contract. How do we communicate with it? We do it through maybe something like an interface, right? Or we can manually encode our call data, but preferably it'd be much easier to have an interface that is going to define how that hello world works in a more human readable way. So what that actually looks like in code is maybe something like this, right? This interface up here at the top, it says I hello world. That's a pretty common thing that you'll see with interfaces. They'll put like an I in front to indicate that it's an interface. You'll notice for the interface there, the function is not fully defined, right? That hello world method does not have a function body. It actually doesn't say what the hello world function does. That's because an interface's job is to make it so that you can interact with a smart contract, right? So if you have an interface, you could say, okay, I'm gonna use this thing to tell Solidity how to communicate with that smart contract, and then we're gonna have this other contract that's gonna say, okay, I'm going to go ahead and communicate with it by taking an address, right? You see that hello world address that has an underscore there? It's being kind of wrapped in this interface. So we're basically saying this address behaves like a hello world. And what a hello world does is it has a hello world method that we can call. And in this case, the hello world method has no arguments. So this right here is valid Solidity. We could totally use this if we wanted to. It should totally compile, at least in the most modern Solidity versions, right? So this is an easier way of doing it, but behind the scenes, again, with that line right there, I hello world calling hello world function, behind the scenes, again, is creating that call data so that Solidity can interact from one contract to another, right? So another code example here is an ERC20, right? We're gonna be doing a lot of stuff with standards tomorrow. So like NFTs, you'll see all the capture the flags, all the flags are going to be NFTs. So you'll get an NFT if you capture the flag. So we'll have a blue, yellow, red, and green flag throughout the exercises. And you'll have to capture them by minting the NFT through a contract that's going to have a bit of a challenge. This particular one is an ERC20, and we have an interface to the ERC20. So if we wanted to, from one contract, talk to an ERC20, the first thing we have to do is define to a contract, how does an ERC20 behave? And that's what that interface is doing. The interface is saying, this is how an ERC20 behaves. It has a transfer function that takes an address and a uint256. The address is who you're trying to send tokens to, and the value is how much you're trying to send to somebody, right? So we can see from my contract below, we're saying do something. It's going to take an address, token address, and then an address to. And what we're doing is we're saying, okay, this token, we're going to transfer to the to address 5 of these tokens, right? So this is how you might interact with like an ERC20 or any other standard, right? Like if you're doing an NFT, you might use any of the number of different NFT standards, and you would take an interface to that standard and to be able to interact with that thing, right? This is the importance of standards and interfaces, is we can do things like have a decentralized exchange that doesn't really care about listing tokens. Anybody can list a token because you all have that similar standard, right? So to communicate with other contracts in Solidity, I talked about this first one, method definition. Interface is going to be the main way to do that, where you're defining what the contract looks like, and then you are sort of taking an address and saying that address behaves like this. That's one way of doing it. There's 2 other ways of doing it that we're going to be talking about today and tomorrow, which are call and delegate call. And I want to just quickly touch on the differences between these 2 before you guys dive into exercises. So call is going to be a way, it's going to be like the low-level way of communicating with smart contracts when you have Solidity. So instead of using an interface, you could do something like use call, like how we did in this exercise over here, and you could construct your own call data. Now, Solidity has some like easy ways of constructing call data that we'll see in a moment. So you don't necessarily have to construct it from scratch like I did here, right? By going out and hashing and then grabbing the argument and padding it out. There's some other good ways of doing it. So we'll kind of see those as we go along. The important thing to notice about call here is how the context changes across the transaction, right? So a really cool thing that has probably been a big part of the reason why you guys are all here today is with Ethereum, you have this ability to be able to like compose on contracts, right? You have many contracts that can communicate together. So you can have like one person who is communicating with a contract, and that contract can communicate with another contract, right? And that contract could communicate with another contract. So all of this is happening inside of one transaction, but there might be many message calls, right? And these message calls are all going to contain call data that's going to be encoded exactly the way that we showed you here just a moment ago. So in this example, we have an externally owned account that's like you or me typically, right? I mean, this could also be a bot. If you just have a bot running with a private key or something and you just sign messages and send them through. But typically we think of an EOA as a person, right? A wallet, something like that. It's going to call into a caller contract. And inside of that caller contract, there's going to be something called a context. We're going to be referring to this as a context for today and tomorrow, which is going to be a bunch of global values. And these global values are going to change based on who's calling the contract and how they're calling the contract. So in this particular case, the EOA calls the caller contract. In the caller contract, there's going to be a message sender and a message value global. The message sender is going to be the EOA's address, so the person originally calling it, and then the message value is going to be the EOA's send value, so whatever ether they're sending through. Finally, with the target contract, the caller contract is going to call into the target contract, and when it does that, you'll notice that the globals down there below in the dotted line change, right? They go from being the EOA in the first context to being the caller in the second one. So this might be exactly the way that you would expect it to behave, right? Like if you're calling a contract, you would expect the message sender to be the person calling the contract, right? If that's an EOA, that's what it's going to be. And then for the target contract, it's going to be the other contract that just called it, right? This seems like it's probably the most intuitive thing to think of when you're doing a message call from any person to another. You would expect the message sender to be the person who just called it, or the smart contract that just called it, right? One important thing to note here, I wonder, it's so hard to call on people for questions since we have 3 rooms, but I wonder maybe if somebody wants to shout it out, maybe you could shout it out in the other rooms, I won't hear you, but the mentors will. Does anyone know in the target contract what global you could use that would represent the EOA in this instance here? Transaction.origin. Yep, I heard it in my room. Maybe you guys also said it in your rooms. If you do, kudos to you. I'm just going to imagine everyone yelled it out in the other rooms. So transaction.origin, that's what it is. So if you're in the target contract, the global that's going to give you access to the EOA there is going to be the transaction.origin. I've said it 3 times now. It's a bit of a hint for the second capture the flag. So cool. So we'll keep that in mind there. Cool. So, and then the other thing that I'm going to talk about is delegate call. Delegate call is going to be just like call. It's going to be calling into another contract, right? Sending call data. It looks exactly the same as call, but it's very, very different in that the context is different. So what actually happens in delegate call is when one contract calls into another with a delegate call, it actually executes on the context of the original contract, right? So if contract A calls contract B with a delegate call, contract B is actually executing code on contract A storage, message sender, and message value, among other globals. So this is going to be a really interesting concept that we're going to be diving into today. Delegate call is, if you are somebody who's very security minded, it is probably the #1 way that smart contracts get hacked, that things go wrong inside of Solidity, that things go wrong inside of just like EVM code in general. Because it's a complicated thing to get right. And when you do a delegate call, you're giving somebody access to your storage, right? If that's potentially, like you can imagine a scenario where you delegate call into an ERC20 token and you don't know what that ERC20 token looks like. If you just delegate call into any ERC20 token and anyone can put whatever ERC20 token they want to in there, that's, you know, a huge security hole because they can change your storage, right? So the delegate call is something that you want to work very, very closely with. You want to be really careful with how you use it. It's going to be one of the main ways that you're going to see hacks and bugs occur inside of Ethereum. So we'll talk about the delegate call and diving more into it. You could think of the call and delegate call as being the same, except delegate calls behaves differently when it comes to context, right? What storage you're operating on and what globals are going to be. Now, this is the last thing that I want to talk about, ABI encode with signature. You guys are going to see this in your exercises, so I'm not going to dive too much into it for now. But ABI encode with signature, what it allows us to do is it allows us to specify a function name along with its arguments, so we're able to make a call data really easily. So what it'll look like in Solidity is if I had a contract over here and I wanted to like call into another contract. Now obviously I don't have another contract here, but if I wanted to call into another one, I would say ABI encode with signature, right? And I would like, maybe if there's another hello world out there, or maybe if there's a deposit, right? Like that's a really common function in Solidity. We'll do deposit like some uint, and then we would pass in the arguments. You do have to be careful here and put deposit uint 256, I believe, and then we could pass in some arguments. This right here will actually construct call data inside of Solidity. So we could take this and we could do something like taking an address, like if we wanted to communicate with the address 0, we could call into it and pass this call data, right? Or we could delegate call into it, which remember is the one that you want to be really careful with, because when you delegate call, you allow somebody to operate on your storage, right, and on your context. That's something you want to be careful about. But otherwise, these two are going to look very, very similar. We're going to be able to take some call data, be able to pass it through the call or delegate call, and this is going to be the crux of the exercises for the next, for the rest of this up until the break, and then up until lunchtime, we're going to be working through some of these things. So, yeah. There is one more thing that we should talk about before we dive into the exercises. That's the fallback function. The fallback function is a function that gets hit when no function matches, right? So we talked about this, right? So like over here, if I have a fallback function, it's going to look a little like this, right? And if I try to call hello worlds with an S, right? And I tried to call hello worlds, maybe I got the method wrong. What that's going to do is it's going to change my signature, right? Hello worlds wouldn't be this, right? I'm just going to increment it to 3.0, but we know that this signature is not going to match any function on it. So what's going to happen is it's actually going to call the fallback function here. The fallback function is sort of what gets called when nothing else gets called. So if one really cool feature of Hardhat is they have a console.log. If you guys are coming from other languages and you're like, wow, great, console.log, that's amazing. For us in Solidity, you know, especially coming from the early days, it took so long to get a console.log in here, and it was such a relief. They really killed it with that feature. So we actually get a console.log here. We can maybe just do a message and say hello. This message right here is going to get triggered because I am targeting a function that doesn't exist on the smart contract, right? I changed the signature around. So now X is not going to be 0 at the end of this, or 7, it's going to be 0. And if I call this, we'll actually see in the log here that it says like hello or whatever I typed in there. So let's go ahead and see. There it is, right? Hello. So what ended up happening here is I changed my signature just a little bit. So Solidity says, I don't recognize your function anymore, so it fell to the fallback function, right? If there is no fallback function and you have a signature that doesn't match any of the methods, this is going to create an error. It's going to revert the transaction. So a fallback function gives you the ability to capture situations where people call it with data that doesn't match any of the signatures. The final thing I want to point out with the fallback function is we can log out here the data. This is going to be the call data that's getting sent from the test cases here. So the call data that I was talking about that we created ourselves. For this one, I do need to say console.log bytes. So that's one thing that I need to put in there. But we should be able to see the exact call data that we created on the test side being passed in here. There it is, right? So there's the signature. I incremented this to 3.0, and then here's the rest of the value all the way padded out to 7, right? So we can see that call data is being passed through on this global message.data. Okay, I threw a lot at you guys. If you retained all of that information, I think you'll kill it on the capture the flags. What we're going to do next is we're going to start to dive into activities, because I know this was a ton of information, and the best way to sort of like get this all in your head is to actually dive in and start like coding this stuff out, right? So what we're going to do next, I expect a few of you are going to need some help on this. We're going to dive into these different classrooms. So if you if you actually joined your team, if you joined like the unicorn or the castle or whichever team you happen to be on, I pinned a message up at the top here inside of Discord. There's like a pinned message if you click on that up there, and you can kind of always grab it. So if you have a lot of chatter in your room, you can always just go back up to the pin. And what this is going to do is it's going to give you access to a classroom on ChainShot. And inside of that classroom, you're going to have all the rest of the people on your team in that classroom so you can work together on these exercises. The first set of exercises are going to be call data. So it's going to be going over call data. So the way to use this platform here is you're going to see that when we dive in here, I can already see some people from Team Unicorn are in my room. I can watch other people if I want to see what other people are doing in my team. Maybe I can even like turn to them and just say, hey, like, how'd you figure this one out, right? We want you guys to work together amongst your team. You know, don't do cross team because they're going to try to beat you and capture the flag. You got to be very competitive here, right? No, you could go cross team if you want to. But you can see other people in your team. You can see as they join in. You can see how many stages they've completed. So maybe you can get a feel for who's like really has good skills here, and maybe like ask them some questions if you're a little bit behind. To get started, what you do is you come over here to stage actions, and you click on code exercises. This is going to bring you into an IDE that you guys might find familiar if you did the prerequisites for ChainShot. And you're going to be able to come over here to the stage task, and you can take a look at what your goal is for this particular stage. And if you pass it, for this particular one, what we need to do is we need to communicate from the sidekick to the hero through the hero interface, right? So we talked about this in the slides. We could do an hero, and then what do we want to send through? Send alert. And we can run the tests. So we can click it up here, or you should have a shortcut that's Control-Enter or Command-Enter. And look, I did something wrong. Send alert is not visible, it's alert. Yeah, okay, so it's alert, right? Because that's what's defined on our interface there. And if we go ahead and run the test there, then we should see that I passed the first set of test cases. I can move on to the next stage, or I can help my teammates. If somebody else needs help on this, you could see that I completed the first stage. I can turn to them, help them out. So that's what we want to see, a lot of interactivity. Ask the mentors, ask me, ask Al. We're happy to help you guys out as you go through these things and start to get more familiar with interfaces, call data, all this stuff. It's going to be really helpful as you go throughout your Solidity journey. Shout out to 0xF16 has already completed stage 1, so you're in there. Cool. If you guys have any questions, let us know. And I'm just going to leave the presentation up here. In about a half an hour, 25 minutes from now, we're going to take a break. And you guys can get up and walk around. So just, try to get through as many of the stages as you can in 25 minutes. If you finish early, try to help the people in your vicinity, right? Try to help them out and help learn all these different concepts. So I'll see you guys on the floor. Yeah, let us know if you guys have any trouble with like the Discord or any of that stuff. We'll set it up for you. Okay. Oh, sweet. Okay, perfect. Thank you.
If I could, I'd be your man. Hold you down the best I can. If I could, I'd read your mind. Make you happy all the time. 'Cause I get so tired. So tired of losing. What's on your mind? It's so confusing. If I could, I'd change your world. Make you proud, be my girl. Do my best to stick around. Pick you up when you feel down. 'Cause I get so tired. So tired of losing. What's on your mind? It's so confusing. 'Cause I get so tired. So tired of losing you. What's on your mind? What's on your mind? It's so confusing. Hollow place.
that you're dead. Fuck it, I'll try. I'll make them cry like you made me do. I don't get well, I get them hell. Taught me to. I just had a sad dream. I think you love me. I'm too lucky. Woke up still. I think you and me. They say, oh my God, Jesus Christ, he was standing by me, blue eyes all the same. But if I lied, I told a joke of the summer, and now I'm full of you. Pull me through to the room, it's getting louder, and you don't see her there. God, I swear my enemy is there. You'll never know. You wouldn't believe her.
Okay, hey everybody. For the next half an hour, we're going to go on a break until 11:45. So you're more than welcome to continue through these exercises and continue working together as a team. One thing we're going to actually put up on the screen in a moment is just some icebreaker questions. So be sure to just get to know the people on your team. These are the people that you're going to be working with on the capture the flag exercises. So get to know each other. We'll put some icebreaker questions and stuff like that. Socialize a little bit and continue to work on the exercises if you like. We'll also be tossing some resources in the Discord that's going to be helpful for the next activity. Things like getting familiar with Hard Hat and getting Hard Hat installed. That's going to be really helpful for the next set of exercises, and especially for the capture the flag stuff. So, we'll take a break and we'll re-adjourn at 11:45. See you guys then.
to spare, and you drove up to the orchard. There was no one on the road that day. Standing in the parking lot, you realize you left all your cash at home. Oh no. Just when you had thought you crafted one fine thing for yourself, it's gone. But from behind the door slams and all your worries fade. As you turn, she's there. And I can't tell you what it's like the moment at the orchard. I can't tell you what it's like. And after conversations you never known to go so well, she offers to buy you in. You say you will pay her back. She laughs and with a grin she says, this one's on me. By the afternoon you're holding hands, picking apples off the tree. Just in case the sun sets, you're holding on to everything you see. And I can't tell you what it's like the moment at the orchard. I can't tell you what it's like. No, I can't tell you what it's like the moment at the orchard. I can't tell you what it's like.
Oh, sure. Yeah, so, yeah, no, we do that. Like, so there's still a lot of we're just sort of like, here, sign up. Yeah. Oh, so you're running home now? Okay. Yeah, I mean, I feel like we started off with cars. It might get a little bit more accessible, but yeah, I totally understand. Well, yeah, take care, man. Hey.
I didn't know what I was on about.
Yeah.
I think I'm finally getting over the drought. I start to ramble and I open my mouth. I think I finally got it figured
That's how
out.
we think about it.
He wants
Yeah,
to
it's
know
like
me,
so much of this stress is action, right?
I
And
think
like,
about
whether
it
it's
every
action
then
you get,
and
you
now.
realize
I didn't know what I was on about.
pull our way out.
I think I finally got it figured out. Mirror on the wall. Money, leave me alone. Heart in the air.
Yeah, so I think Cody extended it.
I think I think about it too much now. I think I try too hard to figure
But
it out.
yeah, there's this one.
I didn't know what I was on about. I think I finally got it figured out. Mirror, mirror on the wall. Money, heart in the air. Baby,
Yeah, I think so. Yeah. He reached out, dude. Like, I want you to get my body. Okay, cool. Oh, man, that's new show. Yeah. Whoa.
I think I thought about it too much now.
Oh, cool.
I think I finally got it figured out.
That's the best people, is, like, on Web2. And then you can just apply all that and, like, learn the Web3 stuff and get up to yeah, that's how it always is, yeah. It probably feels like 40 years. Everyone's like, you're in from like 2018
It's time to pack up.
for a while.
Just you and me and when we go. This scene is meaning, it's making me cold. Day in and day out, it's getting pretty all day.
Yeah, well, that'd be phenomenal. Yeah, if you like what we're doing today, that's more of this.
Going when we start this trip. 'Cause I need you to
Probably actually going to kick back off. Yeah, that's fine. Yeah, so we're gonna do a bunch of like local exercises tonight. So like anyone can environment, because like the stuff in the browser is great. That's what we're doing.
A left turn that we didn't see. Blue tide in Mississippi. But through the south, we'll make it no doubt. Change the tune of what we're singing all about. But tell me how to get started. 'Cause I don't know where to begin. 'Cause I need you to know where to go. Without you, don't think that I would know. Without you, I'd be lost and all alone. So will you tell me, baby, where to go? 'Cause I don't know where to go. I don't know where to go. Cause I need you to know where to go. Without you, don't think that I would know. Without you, I'd be lost and all alone. So will you tell me, baby, where to go? 'Cause I don't know. I don't know. To go.
All right, everybody, we should be getting back from the break pretty soon. I don't want to make a mad rush during the next break, but we do have hats downstairs now. They're pretty cool. I like them. I've been so excited about hats for so long that now that we finally have them, definitely check them out and grab yourself a chain shot hat when you get a chance. Cool. So when we get back from break, which is about now, what we're going to be working on next is going to be local exercises. So we just did a whole bunch of exercises within the chain shot classroom. And that's always great, like getting more familiar with just like the syntax and everything like that. Hopefully you guys were able to make it through a few stages there. If you didn't make it all the way through, don't worry. They are tough stages. What we're going to do next is we're going to like take things a little bit more locally, right? I mean, at the end of the day, the whole goal of what we're doing at ChainShot and what we're doing here today is to get you guys to be able to build projects, right? So what we want to do is we want to take the same exercises and work on them locally within our own IDE. So that's going to be the focus of hero calls here. And it's going to be kind of a similar set of exercises with like call data and delegate call and call, but we're going to be doing it in our own local hard hat repository. So I'm going to show you guys how to get that installed, and then I'll send that over to you on Discord so that you can go ahead and do it yourself. So let me go ahead and get started with that. We're going to have a GitHub repository that we're going to pull this all down from. So let me just go ahead and do that. So we'll have, if I go over here to GitHub, and then we go to, let's see, it will be hero calls. That's right. Forgot what I was doing for a second. Okay, so we're going to go over to hero calls. This is the repository I'm going to send over to you guys. And essentially the way it's going to work is there's going to be a set of exercises, but these exercises are going to be entirely on your machine. So you're going to have to like pull this repository down, and then you're going to have to run the test cases yourself. I'm going to show you how to do that slowly. If you guys want to follow along with me, I will drop this link in the Discord now. So let me just toss it into like announcements to kind of make sure it doesn't get swamped there. So these are hero calls. we're going to pull this repository down. Again, this is another one where there's going to be 5 exercises. If you don't get through them all, no problem. Especially the last one's pretty tricky. So, you know, that's out there for people that are feeling really comfortable with this stuff. But if you just get through a couple of them before lunchtime and you like kind of ask us if you have any questions about like setting up a local hard hat repository, that's really what we're trying to do here, is to get you guys familiar with running test cases, getting familiar with your local environment, that sort of stuff. So yeah, I'll go ahead and drop that in there. And then when you're ready, the goal here is to go ahead and pull down this repository and then start modifying it. So what I'm going to do is I'm going to go ahead and clone this repository. Let's go ahead and do this over here. So the easiest way that I find to clone a repository is I just kind of like use git clone locally. We'll help you guys out if you need any help with, if you don't have Git installed, you might actually have to install Git if you don't have Git installed, or you can kind of go to their clone UI in the repository. We'll show you guys how to do it. So somebody just asked the question, where is the link? It's in the announcements channel of the Discord under Web3 EXP. So you can find it there. And yeah, so we'll go ahead and clone this repository. Easiest thing to do for me is to just do git clone, which is the git CLI, and then go ahead and put the URL in there. I guess I already have the repository, so I'll just go ahead and kill it. Oh, so some people are saying that they can't find the announcement channel in Web3. If you can't find the announcement channel in Web3, the only thing you have to do is just click on the little ta-da here inside of the choose channel with the robot, and then that's going to open up these other channels. We just do that so other people in the Discord don't get bombarded with all the other messages, so that just unlocks it for you. I can see a lot of people were confused with that because now we have a bunch of ta-das. That's good. Cheers. Yeah, awesome. Okay. So we'll go ahead and clone this repository now. Really? Oh, man. Oh, it's there? Okay. Everyone good? Oh, we have a lot of questions in here. Don't worry, guys. I'll get you the repository in a moment. So if you don't have it now, I'll come around and make sure you guys all have it. Okay, so we have to get hero calls. What I'm going to do is I'm going to open this up into my own IDE here, which is going to be Visual Studio Code. And what this is going to set you up with is 5 contracts and 5 tests. The goal here is to go ahead and modify the contracts such that they pass the tests. So the README is going to be like your set of instructions here. So as opposed to what we had a moment ago where we were in the browser and you had a set of instructions, the set of instructions is going to be inside of the README here, the markdown. So for each challenge, your goal is to modify the contracts and then run the test cases to be able to test whether or not you passed it. So once you pull the repository down, and I'll write these instructions out in announcements as well, once you clone it, the first thing that you should do is you should npm install, which is going to go ahead and pull all the dependencies that you need into this particular repository and store them in node modules. And once you have that set up, then you can actually start running the tests. So I'll let that install. And then you can run npx hard hat test. Now, what you might find is for this set of exercises, it might be easier to just run one test at a time, because you see I'm getting a lot of error messages here, right? So at first, the tests are not all passing because you do need to change the contracts to make them pass. If I want to run one test at a time, there is this instruction inside of the README where you could say npx hard hat test, test1.js, and if I just run this one here, it'll just run the first set of test cases, right? So it's telling me, hey, this is not working. Something's going wrong with the first contract. So what I would do is I would look at challenge number 1, and I would see, okay, open up contracts1.sol to check out the first challenge. Inside the sidekick contract, you'll see a to-do to alert the hero. Complete this call to successfully call the hero's alert function, right? So this is probably pretty similar to what we just did, right? Some of these exercises are going to be a little different. But this is going to be doing it in our local environment. So here you can see we have that ABI encode with signature, and you'll see the hero down here. So again, we're trying to alert them, right? So all we have to do with this one is just put alert in here, and then we could take out the to-do, and we should pass our first set of test cases for npx hard hat test 1, right? Now we're passing, so we know that we completed exercise 1, and then we would go on to exercise 2. We could run the test cases for that. We'll see an unspecified assertion error. Go look up the task, and then be able to pass all those tests. If you pass all the tests for this one, then you have successfully completed the exercises. Make sure while you're doing this to also check out the test cases. So if you're not familiar with unit tests, just check these out to get a little bit familiar with like what's going on behind the scene and how we're interacting with the contract. Because this is something that Al's going to go over after lunch. But if you get familiar with it by just looking at these things, that's going to be really, really helpful for you guys going forward in the afternoon. So yeah, I'll be around for any questions. All the mentors will be around for any questions. Let us know. If this is your first time using Hard Hat, we don't expect you to like, just be able to jump in here and start doing everything. So ask us questions. We're more than happy to help you get set up with all that. And yeah, we'll continue working on this for the next hour, and then we'll take a lunch break from there. So yeah, if you guys have any questions from the earlier exercises too, we're happy to answer those. And we'll take a lunch break, and when we come back, we'll start talking about unit tests, and we'll do the capture the flag exercises, where you guys want to get really familiar with all your team members, because those are the people that you're going to be working with during the capture the flag exercise, which should be a pretty tough one. So yeah, we'll take an hour here to work on these exercises, and I'll see you guys on the floor.
Someone is not seeing the
Yeah.
channel.
So what they have to do is they have to go to
she only
choose
sees
channel
this one.
and
yeah?
then click the to-da there.
Okay, thank you.
Sure. Yeah, yep, exactly. Yeah. Is that good? Okay. Sure. Okay, great. Thank you so much. Good. About to announce lunch. Yeah. I think I took this over. Oh, okay. Yeah, I was just gonna review some. Yeah, I was just gonna review some stuff real quick for them, and then break for lunch. Maybe I'll review when we get back. I mean, are they ready for lunch? I guess that's why she said it. She said, like, are you gonna announce that they can do it outside? Yeah. Maybe we'll do that. Yeah. Okay, everybody. So what we're going to do is we're going to take a lunch break here. So we're going to take an hour for lunch. When we come back, we're going to discuss some of these challenges here. These were really difficult challenges, and I was surprised to see that quite a few people made it all the way through. We'll discuss the reasons around like 4 and 5 and exactly what they mean when we come back from break. So feel free to continue to work on those. We'll also be tossing more stuff inside of the Discord. So for lunch, the lunch is going to be downstairs, so you guys can join us downstairs for lunch. As far as like seating, you can also sit on the terrace outside. So if you look outside in the courtyard, you can go out there and eat lunch out there, as well as you're welcome to bring it back up here. So we'll go ahead and break up for lunch, and yeah, I'll see you guys out there, and see you guys when we get back from the lunch break around 1:50.
You're so personable, and I just can't talk right. And I'm so reasonable, but you just want to fight. You make me feel kinda strange, baby. You make me feel just like time warps to your behavior and your opinions, right? You make me feel kinda strange, baby, with the feelings that I like. They tend to come same moments, and they just timed out right. Was I right? Your mouth makes an awful sound when you tell me you don't care. My ears get awfully loud when I told you it's not fair. You make me feel kinda strange, baby. You make me feel just like time warps to your behavior and your opinions, right? You make me feel kinda strange, baby, but the feelings that I like tend to come at the same moments, and they just timed out right. Out right. Out right. Were they right? wish you could see me on a good day. I wish you could see me. I don't get out a lot, especially when I am feeling off. I got no energy. I got my intuition telling me all kinds of things, but I think I give it up just how it's supposed to be. I try to keep myself out of the most of it, so I am constantly just moving out the way. And I could give a fuck about your reason. I think I'm gonna stay here where I feel alright. I wish you could see me on a good day. It's not fair, our life just leave me here to die. And I love how you just happen to be right here. I'm doing everything to just get by. You had to be around the day that I'm here, so I thought I wouldn't see you here this time. I guess it's my fault. Let the day I'm feeling on. I don't talk a lot, especially when I am feeling off. Not a good recipe. I get all timid at the way she comes and talks to me, so I go off in the distance where I'm supposed to be. I try to keep the present from the personal, so I need to get away from the commotion. And I can't give a fuck about the reason. Think I'm gonna stay here where I feel alright. I wish you could see me on a good day. It's not fair, our life just leave me here to die. And I love how you just happen to be right here. I'm doing everything to just get by. You had to be around the day that I'm here, so I thought I wouldn't see you here this time. I guess it's my fault. Let the day I'm feeling on. And I wish you could see me on a good day. You could get to see where I'm from, and let me know what you think is a good day. And I could be the one you could lean on. I wish you could see me on a good day. Feel like someone else when you are gone. Let me know what you think is a good day. I wish you could see me on a good day. It's not fair, our life just leave me here to die. And I love how you just happen to be right here. I'm doing everything to just get by. You had to be around the day that I'm here, so I thought I wouldn't see you here this time. I guess it's my fault. Let the day I'm feeling on.
Beat oh beat, you know the muscle hits the brain sometimes. Try to replicate a photo, are you satisfied? Is it knowing that makes you mine? All the knowing that we were running out of time. All that those were looking like a fade away. Played a painting out of way to make a picture last in time. Took a Polaroid just to make it stay the same. Don't move, don't move.
behavior and your opinions right. You make me feel kinda strange, baby, with the feelings that I like. They tend to come at the same moments, and they just timed out right. Was I right? Your mouth makes an awful sound when you tell me you don't care. My ears get awfully loud when I told you it's not fair. You make me feel kinda strange, baby. You make me feel just like time warps to your behavior and your opinions right. You make me feel kinda strange, baby, but the feelings that I like tend to come at the same moments, and they just
Keep it up, be on time. It's myself if it's not someone else's bed. Turn it up, I feel fine. 'Cause what's my life if it's not equally fulfilling? I hope you never close your mind. You should keep it on the captions, pictures you share. Keep it up, this is so relatable to you. Or is it the way that you wanna be seen? Is it the basic sense of humor? Take it to the stage, it's up on the screen. I feel fine. Keep it up, be on time.
gets left behind. Wise words they tend to give are sometimes hard to live. You're finding peace of mind. You're finding peace of mind. You're finding peace of mind. Seeps between the leaves, feel it touch you in the breeze. Your senses intertwine. Fold to the silence in your brain, and thoughts you've yet to gain. You're still finding peace of mind. You're finding peace of mind. You're finding peace of mind. eyes. Think I'm done trying to hide. You can't clip my wings from the last time. One day got me back on my feet. So soft like a Georgia peach. Life's always a bit bittersweet, but what do you know? I found a feeling. I found a feeling. Sleeping till around 2. This world's gonna hit soon. Just soaking in these better days. One day got me back on my feet. So soft like a Georgia peach. Life's always a bit bittersweet, but what do you know? I found a feeling. I found a feeling. I found a feeling. I found a feeling.
I used to think I was better off keeping cool in the midst of love, steering clear of hurting anyone. Life takes me over. It's something nobody tells you. Everyone that you love will let you down, try to fool you into thinking there's something at the end, but I know better. Killing time's a mistake that I regret. I should enjoy till
look at me drool on my old ass cardigan. Hope that you're flattered, cause I'm falling apart again. I'm hypnotized, I'm paralyzed. He's hypnotized, he's paralyzed. My drool forms an ocean and I sail out to sea, the sea of embarrassment in me. Well, I'm the captain of my own ship, a ship on the sea of embarrassment. You can't teach an old dog new tricks if the old dog's brain ain't wired for it. Why am I so attached to everything? Why is he so attached to everything? Dinner served on time again, a greeting from you. Well, I just checked my calendar, I've got nothing to do. I've got nothing to do. I'm hypnotized. I've got nothing to do. I'm paralyzed. I've got nothing to do. He's hypnotized. I've got nothing to do. He's paralyzed. I've got nothing to do. I've got
Life is brutal, life is beautiful. You know I hate to see the morning. Life at this hotel is so desirable. The end of everything you're wanting. You watch the waiter, the elevator. Looks like he's coming down the mountain. I miss the complimentary breakfast. Gee, Life is wicked when you're conflicted. Maybe I'll see you in the morning. And if I don't, well, I'm at the hotel where everyone is gonna go.
Okay, we're gonna get started in just a moment here. We're gonna be getting back from lunch. I did get a couple requests coming back on the way to explain some of the challenges that you guys went through on the hero calls. So we will definitely dive into this stuff and talk about it a little bit more. After that, I'm gonna show you guys a couple hard hat features that'll be really important for the capture the flag. I want to make sure that you guys understand those because when we dive into the capture the flag, it's going to be really predicated on knowing that knowledge, like being able to like connect with a JSON RPC endpoint. That type of stuff is really, really important. So we'll deploy a smart contract together, walk through that process, and then I'll hand you guys off to the capture the flag. You should have received a private key in the Discord for your particular team. So you may see that in there. Don't share it with the other teams. That is your private key. Also, please do not use it for any mainnet funds at all. Like, those private keys are compromised. Never use those private keys. But they are a good way for us to see who is actually completing the challenge, and we can actually compare that back to the team, right? So we can see that if Team Ghost is the first one to capture the flag, we can kind of compare that back and give the 5 points to Team Ghost. So, guard that private key with your team's life. And yeah, we'll get underway with just kind of like talking about these contracts here. And I'll talk about the reason why we had you guys go through some of these. I know they were a bit challenging. In fact, they were very challenging, especially contracts 4 through 5. I didn't expect so many people to get through these, and I was really impressed. I mean, I don't know how much experience a lot of you guys have, but it seems like everyone's really picking up on this stuff super quick. We did come in here at a really high level in terms of like the concepts that we're talking about here, and I'm just really blown away with how well you guys are taking it so far. So awesome work on that. Yeah, let's go ahead and dive into these different contracts. So before we left for lunch and before I kind of left you guys off on the hero calls, I talked about this particular exercise, right? And we're pretty familiar with this concept by now, encoding, function, and then just being able to use encode with signature to be able to create the bytes and be able to send that over to a smart contract, right? So this one was pretty straightforward, and we already ran that one to make sure that it worked. For the second one, this was another one where like basically extending from some of those exercises from before, we could basically just kind of copy what we had here if we want to cheat a little bit and just take a look at the signature down below, right? We have this alert, and the alert is going to take a uint 256 and then a bool. And so now we can actually go ahead and pass those over and pass the enemies in here and whether or not they are armed. And we're being a really good sidekick at this point. So we can go ahead and npx hard hat test for test 2, make sure that is working. So we're getting really, really comfortable with call data, right? Creating call data. Like I said, like typically you don't do this kind of low-level call into another smart contract but it is really good to know that this is happening behind the scenes. And also, like, if you were to do anything like really dynamic, like if you were going to build a multi-sig, or if you were going to build like a governance protocol or something like that, typically you will accept call data from the front end, because what you're going to do is you're going to accept any type of transaction that that person wants to make and put it through whatever governance process you need to. And out the other end, then that governance process can create a transaction, right? So dealing with call data is not something that is uncommon. It's definitely more of an advanced thing, but you guys are really getting the hang of it, so that's amazing. For this one, okay, so this admittedly got a little bit ahead, and hopefully this didn't trip too many of you up here, but I definitely wanted to try to give you guys some challenging ones to really like get you in this mindset of digging into smart contracts here. So for this one, this is a pretty common way of sharing storage layout across smart contracts. So what actually happens inside of the test cases is we're going to deploy the sidekick and behavior separately. So if you take a look inside of test 3, these actually become 2 different smart contracts at 2 different addresses, right? So we're going to put the behavior out, and we're going to put the sidekick out somewhere else. And then the thing here is basically we just want to check that after sending the alert from the HQ, it should record the ambush. But if it doesn't come from the HQ, then it should not, right? It should revert here. And so for this one, essentially what we wanted to do was we wanted to use the behavior's record ambush to store the ambush. So what you could do here, calling in from the sidekick into the behavior, right? We're like calling another smart contract. We could use this address right here and do like a behavior and then call. But the thing here that we wanted to do is we wanted to actually have this ambush affect the sidekick storage. One thing to really take note of here, and this is a really important and subtle point, this contract, consider it having its own storage, has its own storage, right? It has its own set of storage layout. And then this one down here has its own storage layout. So every smart contract that's deployed has its own set of storage layout, right? So whenever you deploy a new smart contract, all of its storage is going to just be zeroed out, right? You're going to have a bunch of possible storage locations that you can store. They're all going to be 256 bits, and you can store whatever you want inside of there. So sidekick and behavior are going to have their own storage, but both of them are going to inherit. That's where this is coming from. They're going to inherit from this storage contract where they're both going to essentially have the same layout for the same variables. So when we actually refer to the same variables from sidekick into behavior, we can actually do a delegate call here. And what's going to actually happen is we're telling behavior, hey, you can modify my storage. And as long as they're referring to the same like storage variables, this is actually going to modify the expected spot in storage, right? So this right here, this delegate call is what we wanted to do. We want to pass this into, and we want to do something very similar as we did before, ABI encode with signature. Let's go ahead and pass that through and do a record ambush, a UN256, bool here, pass in the enemies and armed, and pass that delegate call through. And then one other thing that we want to check is to make sure, it's yelling at me, right, because it wants that bool success. I don't know if you guys got a lot of that, but Solidity will yell at you if you don't handle that success. The reason is because if it fails, this actually like silently fails. It doesn't actually revert the transaction. So you could potentially like assume that it passes and then continue on with all the rest of your stuff without realizing that it actually failed. So what this is doing is it's requiring that we actually were successful with that call. And then calling into this record ambush, what we want to do is we want to require that the only person who could have called this was headquarters. Now, the interesting thing here inside of this function, this record ambush, even though it looks like we're modifying stuff on behavior, all of this is actually happening inside of Sidekick, because this delegate call is actually going to tell behavior, hey, modify my storage. So when we say that the headquarters is equal to the message sender, we have to think back maybe to that like original slide where delegate call is operating on the first contract's message sender and also its original storage right here. So behavior is acting as a behavior, as like an implementation for Sidekick, and we were just sort of like proxying in there with the delegate call. So if you've heard of like this concept of like proxies in Solidity, they're often used for upgradability or for gas savings. This is essentially what a proxy is doing. It's going to do a delegate call from one contract into another for many different reasons. And this will about do it for us on that one, I believe, if we do test 3. Unless I missed something here. Okay, so we're in good shape on that one. For 4 and 5, these ones were extremely difficult, and they were actually meant to try to get you thinking. I'm also going to send over some stuff on our next break. These were actually modeled against the parity multisig hacks that happened way back in, I want to say, 2016. Those were some terrible hacks that occurred because of issues with delegate call. And so this one in particular was an interesting one where it says the hero can be hacked, right? So how exactly can the hero be hacked in this scenario? If you take a look at the test 4, essentially what's going to happen is they're going to try to take over the ownership of the contract. So you have like this villain EOA, and what it's going to try to do is it's going to try to send through this initialize function through to the hero contract. So what's going to happen? What's going to happen if we send through some call data that's targeting an initialize function on our hero contract? If we go back to the contracts 4 over here, we have this hero contract. There is no function that matches that target, right? There's no function inside of this hero that matches that target. So where's it going to go? It's going to go into this fallback function, right? And this fallback function, what it's going to do is it's then going to go ahead and delegate call into the behavior. And now that the behavior is over here, it can potentially try to reset the owner to be somebody else, right? And this is exactly what happened with the multisig hack that I was referring to, is somebody was able to set themselves as an owner by being able to go through the fallback and being able to call this initialize on an implementation contract, which then set themselves up as the owner. So right now, the way that test 4 is set up, somebody could potentially hijack the hero contract and then become the owner here, right? That's the vulnerability that we're seeing here. So one thing that you want to be really careful about in a fallback scenario, or really any time that you're using delegate call, is making sure that you don't accidentally delegate call or you don't give this ability to delegate call into a function that modifies a storage variable that you don't intend for somebody to modify, right? This initialize function right here typically is a function that comes on a proxy that once you initialize it, then the initialization is done. The issue here is anyone can initialize this at any given time, right? So the simplest solution here that we were kind of looking for is trying to do something where you just detect whether or not this has been initialized, because we definitely want to do this initialization in the constructor, right? This is something that when you create like a proxy sort of contract like this, you'll often have to initialize it. But what we want to make sure is that we don't end up initializing it again. So we could do something like this where we say is initialized, and then we can come down into here and say require that it's not initialized. And at the end of this, go ahead and make it initialized. And what this will do is it'll make it so nobody can come in and initialize with the fallback, because the fallback, really the intention here was to allow us to proxy to behavior methods, but really the intention was to get them to call the supercharge function, not the initialize function. The initialize function was for like the constructor, the person who was like setting this function up, right? So that'll pretty much do it for number 4, is to make sure to, with your initialize functions, always like make sure that they cannot be reinitialized, or that you don't allow somebody to modify a variable even through a proxy that you intend to keep safe, like an owner of a contract. And then finally, number 5. Sure.
Like requiring that the owner is address 0 is also a good solution, or is it wrong with that?
Yeah, so the question was that would you require that the owner is the address 0? Oh yeah, that's perfect. Actually, I think that's a really good way of doing this without the initialized variable, is saying owner is equal to address 0. This was a question that just came in over in my room. Somebody pointed out that you could do something like this, and then we don't even need that initialize function or that initialize because we're going to set the owner here, unless we set the owner to 0, right? And then we can reinitialize from there. But yeah, this is a perfectly good solution, I think, and should pass. Nice. Good call. That is a great solution. Cool. So contracts number 5. And this last one as well is a really tricky one. Most of the time in all of these stages, you are like kind of like in this frame of mind of like helping out the hero, being the sidekick. But in this one, we actually put you in like the malicious side of it, trying to see what you could do that would potentially like be bad here. And what ends up happening, so inside here, the hero would never call this contract, but are we safe from the bad friends? So what actually happens, so this is the bad friend down here, right? This contract here, and then there's the good friend. And what the hero is trying to do is the hero is trying to say hello into the good friend. The issue here is that the hero is saying hello through a delegate call to the behavior. The issue really comes in that anyone can say hello from the behavior into either the good friend or the bad friend, because this behavior, once again, is not this set friend function right here is one that is open to anybody to potentially modify, right? So anyone can come in here and set this to be the bad friend. The thing that usually doesn't matter here, that's like a little bit weird about proxies, is that the behavior is not the one where we care about who the friend is. Like, you could consider the hero like the protocol in this circumstance, like, right? Like if you had a decentralized exchange, or if you had like a money market of some sort, this is like the main contract where you're trying to like sort of defend the storage variables. Like this is where everyone's storage variables are and where they matter. So the hero is the thing that we're trying to make not like hack proof. And so typically you don't really worry about like somebody coming in and setting something on like a behavior contract like this, like setting this friend here. The reason why this matters is because if somebody can set this friend, they can set this friend so that you can come in here to say hello, and then this friend is now going to be delegated call from the behavior, and we can delegate call into this function here. So now the question becomes, what kind of damage could we do if we were the bad friend and we came in here and set this friend to the bad friend, and then we said hello, and then we got the delegate call into this? What is something that we could do? We could definitely modify the entire storage layout, right? But if we're not worried about the storage layout for the behavior, then that doesn't matter, right? We can't modify the hero's storage layout because the hero's not delegating call into the bad friend. There's no vulnerability inside of the hero, but this behavior is vulnerable. So what kind of damage could we do? Does anyone want to call it out? Anyone have an idea? Yeah, you finished the exercises in like half an hour early, so I knew you had it there. Self-destruct. This is what you could do. You could blow up the smart contract. So if you guys remember that like kind of like famous line, like what did DevOps 199 say? I accidentally killed it. This is exactly what happened. They self-destructed the implementation contract. So if you come in here and you say self-destruct, what actually happens is, again, we are, in this case, because this delegate call is coming from this behavior, it's delegating call into the bad friend. We're operating on the behavior's context. So a self-destruct actually blows up the behavior. And now what's going to happen is the hero is no longer able to connect to their friend because the behavior doesn't exist anymore on that self-destruct. So by actually blowing this up, this will actually make it so the hero can no longer communicate with their good friend, or, you know, in some circumstances, this could be like some important protocol or something that somebody might connect to. And this has come up many times beyond just the multisig. It was an exploit that was in the original Aave v2. It was in a number of different contracts that have been out there. So this kind of thing comes up time and time again. So just be really, really careful with your delegate calls, even if it's inside of an implementation contract, not the one where you actually care about the storage. But yeah, that's a really, really advanced concept. We'll go ahead and test that out and see if we get it through. And cool. So we destroyed the behavior contract, which makes it so the hero can no longer talk to the good friend, which was exactly what we were trying to do there. So these were really challenging. For those of you who got through them, great job. Even getting through 3 of the contracts was extremely difficult, so we wanted to really challenge you with these. We're going to take a step back from this point and make things a little bit easier in terms of what we're going to be working on today and tomorrow as we go into like reference types and that type of stuff. So what I'm going to do now is I'm going to take a step back and like build a hard hat project from scratch with you guys and deploy a contract so we can get familiar with communicating with a JSON RPC endpoint. That's going to be really important for the capture the flag, because what I'm going to do is I'm going to send you guys over an address on a chain, and what you need to do is you need to complete a security challenge. And if you're able to do so, you'll be able to mint the NFT flag and be able to earn points for your team. So we'll go ahead and jump on into that. So let me start just like a brand new repository here, and we'll just deploy some smart contracts. So let's just do like my temporary repos. And we're going to go ahead and make there like a deploy contracts. So I'm just going to walk through this process. Many of you may have done this already before. But if it's your first time, then I'm going to make sure to take it slow so we can kind of go over this. It's going to be really critical for the capture the flag. So let's go ahead and create a new repository, right? And then we're going to go ahead and npm install hardhat. And then we'll go ahead and jump on in there and be able to kick this thing off. So when you want to deploy a smart contract, what kind of server do you have to talk to in order to deploy a smart contract? What do you guys think? Yeah, like an Ethereum node. So I heard Infura, I heard JSON RPC. These are all correct, right? So like the idea is that we want to interact with an Ethereum node, and we want to get that smart contract deployed, built inside of a transaction that's going to get mined on the blockchain, right? So in order to do that, what we need to do is we need to communicate with a JSON RPC endpoint. JSON RPC is going to be the API that we can use to interact with an Ethereum node to send a transaction or to send a transaction that deploys a contract. We can do any of those things from there. So that's what we're going to do here is set up a JSON RPC endpoint. And yeah, you're totally welcome to use whatever JSON RPC endpoint you want to use here. There's several good ones, QuickNode, Alchemy, and Infura, and we'll go ahead and kind of set this up here. So let me, always feels like it takes a little bit longer when we're, okay, here we go. Okay, so what I want to do is I just want to deploy a contract, and we'll go ahead and take a look at that contract on chain. And so let's deploy, this greeter is probably good enough for us to sort of deploy. We have a greeter that has, let's just make this a public. Oh no, it's because there's a greet function that will return the greeting. So let's go ahead and just deploy this contract, right? So this contract, what it does is in its constructor, it's going to take in a string. And the string is going to be a greeting. We could store it inside of this private variable here. And then what we could do is we can later take a look at what the greeting is or change the greeting, right? So if we actually want to do this on some chain somewhere, instead of going into our test folder, what we're going to do is we're going to start to interact with a blockchain through our scripts folder here, right? So what I'm going to do is I'm going to create like a deploy script. And this deploy script is going to allow me to deploy a smart contract. So there's some like, inside of this hard hat script here, there's some just like, what do you call it? Just some bare bones stuff that's going to be here in the beginning. We can get rid of a lot of this stuff. You don't need the HRE environment up here if you don't want it. It'll actually globally inject this, and that's what they're trying to say inside of the comments there. What we're going to do is we're going to go ahead and deploy this contract. And they already have this set up for us to go ahead and do that. The only thing that we need to do from this point is just configure it to talk to the chain that we intend to deploy to, right? So when we're working with a unit test, you are deploying to a chain. Like this right here, when you deploy smart contracts, you are deploying to a chain, but you're deploying to a chain that only exists for the length of you running those test cases. So we're essentially creating a blockchain to deploy these contracts to, and then testing it out, and then killing the blockchain, right? Another thing that you could do is you could deploy to like a local blockchain if you use something like Ganache CLI, right? Or like a hard hat node also has this as well. But we could pull this up over here, and we could do, Ganache CLI, this is going to run a local blockchain on my machine that's going to be available at localhost 8545. And what I could do is I could deploy the contract to this chain. And that's what I'm going to show you guys right now exactly how to do. What we would do is we would come into the hard hat config. And again, this is a lot of cruft that we don't need here. We can set up, and I'll send you guys over some resources on how to do this exactly. You could set up a network. And in here, you can name the network whatever you want. So for me, it could be my local chain, something like that. And in here, I'm going to put my URL, which is going to be HTTP localhost 8545. And I'm going to need an account here that I can go ahead and deploy this with. So I can just take one of these private keys. You want to be careful with private keys whenever you are using them for any mainnet funds here. I'm just going to go ahead and paste that in there. And we can go ahead and deploy this thing out to my local chain. So what I should expect is I should see some methods come in here showing that we deployed the smart contract or some notifications. So now that I have this all set up, what I'll do is I'll go ahead and do an npx run scripts deploy. This script right here, I'm going to go ahead and run from hardhat. So I'll do npx hardhat run script/deploy.js, and the network is going to be exactly what I named it in here, right? It's going to be my local chain. So we're going to go ahead and pass that through. And this should go ahead and deploy to my local chain. Let's see. Okay, here we go. So you can actually see the transaction. Here's the contract created. So this contract actually lives on my local blockchain. If I wanted to see the greeting right now should be hello hardhat. Right? So if we wanted to see that, we could maybe write another script if we wanted to. Let's do something like get greeting. And get greeting in here, the difference is now instead of deploying a contract, what we want to do is we want to actually interact with the contract, right? This is my contract address right here. So this is my contract. We'll call it the address maybe. And so in Ethers.js documentation, you're going to notice that there's two different types of sort of contract objects. One is a contract factory. A contract factory helps you deploy smart contracts, whereas there's also a contract. And a contract is a representation of a contract that you are interacting with on chain. So that's what we're going to try to get here is the contract. So I'm going to go ahead and say I'm going to get this contract at this particular location. And what that's going to do is it's going to return me a contract that I can then interact with and be able to look up something like, let's go ahead and see what the greeter's greeting is, right? And it should be that hello hardhat that we set over here. So we can go ahead and say greeter.greet, and this should return the hello hardhat. So let's go ahead and see if that works. npx hardhat run set scripts /set greeting.js. Network is my local chain. Set greeting is not, get greeting. Oops. Get greeting. And then hello hardhat, right? And we could change this greeting if we wanted to. Now that we have this instance of the greeter, we could say greeter.set greeting is hello devconnect, or maybe what's up devconnect. So we can go ahead and post that in there, and then it will actually come through, right? We're actually modifying that. So if I remove this here, that's actually getting modified on chain. We can see that it's saying what's up dev connect, and we can see that there was a new transaction in here that got mined that actually modified that smart contract on chain, right? So what is the big takeaway here from all of this? The big takeaway, I think, is to learn about this networks configuration, to understand that we can talk to a JSON RPC endpoint. Right now, I'm talking to my localhost 8545, but in a moment, what we're going to do is we're going to talk to another JSON RPC, right? So we'll go and get a JSON RPC endpoint, and then we'll plug it in here, and then be able to interact with it through the accounts, right? So that's what we want to do now. We'll deploy it to like a local chain somewhere. Today, specifically, you guys may have noticed that during the enrollment flow, we had you stake on Optimism, which is a layer 2 rollup for Ethereum. What we're going to have you guys work on today for the chain is going to be Optimism's testnet. So they have a testnet called Optimistic Kovan. So that's where we're going to be doing all of the capture the flags on. So what I'm going to go ahead and do is hook us up to an Optimistic Kovan network. So let's just go ahead and do that as well. Optimistic Covan, and we'll go get a URL, and we'll go get ourselves an account that has some Ether on here. So let me go ahead and do this. What I typically do and what I tell people to do with, so some of you may use MetaMask in like your browser. I typically tell people to use a different browser than the one that you usually use and install MetaMask there as a developer, because if you use it in your regular browser, you're going to want to put it into a different browser, so that way you don't mess up all your different accounts, right? So if you have any sort of like hot wallet or anything like that, you can take it into like, maybe like a Brave or a Firefox or something like that, and be able to have like several accounts in here. So I'm going to go ahead and pull this up. And I have a bunch of test accounts in Firefox, so this is actually just like a pretty crazy MetaMask just full of a bunch of different like test accounts in here. So you can see I'm on the Optimistic Covan network. What I'm going to do is I'm going to go ahead and get us a JSON RPC endpoint that we can communicate with, deploy a smart contract. So I'm going to pull up, you can go to Alchemy, you can go to Infura, you can go to QuickNode, whatever you choose to do. Alchemy.com, right? There we go. And what you could do with all these is you can sign up. They generally have a free tier where you can sign up and get an Ethereum node and then be able to communicate with it. So I specifically have one in here. Oh man, I can't sign in through Google on here. All right, let's go back to Chrome. Log in. And we'll get ourselves a JSON RPC endpoint for Optimistic Covan. And you can see I have one right here. And so what I could do is I can come in here to the view key, and you can grab this HTTP endpoint. And don't worry, I'll put all the instructions in here for you guys to be able to do this. You're going to get an endpoint that is going to give you access to a node that you can then communicate with. This one specifically is going to be on Optimistic Covan. And we're going to go ahead and deploy it out there, right? And now we need an account. I need a really simple account here that I could go ahead and deploy some smart contracts to. So what I could do is, a number of different things, right? So like if I wanted to do a new account over here, I could create an account, let's just say like test stream. So while I'm on this test stream, and maybe we'll send it over some Ether so that I can play around with it, right? And I'll take from this account, we'll send to the test stream, maybe 1 Ether so we can deploy some contracts. So let's just go ahead and send 1 Ether over here. And that should show up in my test stream in just a moment. And when it does, what I'm going to do, and you should never do this, this is the part where I'm like, this is why you should have a test browser for MetaMask. You don't want to ever do this on like, a MetaMask that you are using real accounts for. Ideally you use a cold storage wallet anyway, but what I'm going to do here is I'm going to export my private key. This is pretty insecure, right? You don't want to do this unless you're being a developer and you just want to use it as part of your development flow. I'm going to go ahead and pull this private key over, and I'm going to use it to go ahead and deploy a smart contract to Optimistic Covan using this Ethereum node. So I'm going to go ahead and fill that in. And now I'm pretty much set up, right? My deploy, my get greeting, they don't change. The only thing that changes is I'm going to point this at Optimistic Covan now and go ahead and do a npm run scripts / deploy. And my network is going to become Optimistic Covan, right? I'll go ahead and deploy that out there. And what we should see this time is that we're actually going to deploy something to a live chain, so we can actually go and see this on chain. If we go out to Optimistic, let's see, what's a Covan Optimistic Etherscan, and we can actually go to this address, and you'll see my contract is out here. Now it's interesting, right? You guys may, if you haven't deployed a contract before, you may have expected to see source code, right? You may have expected to see like Solidity out here, but actually when we deploy a contract, we actually deploy it out in its bytecode form, and then what you can actually do is you can come and verify this. It looks like they've already detected that there's a lot of similar contracts, so we could actually verify this if we wanted to. It's going to be our greeter. Now it's on Optimistic Covan, and the get greeting works the exact same way, right? We just point it to Optimistic Covan. We could say get greeting, and then be able to take a look at it from, because it's not the same address, right? We need to actually point it out the new address that we deployed to, and then be able to get that greeting there. npx get greeting. Hello hard hat. We could change it if we want to, and we'll actually see that get changed on chain, right? So if we go back over here, we should see another transaction come in where it's setting the greeting momentarily. Give it just a sec. And greeting doesn't change right away, so we just gotta wait for it to actually get mined. There it is. What's up, dev connect. And we can see the set greeting is actually on chain, right? So it doesn't change up our flow too much to deploy to another network. All we really need to do is come in here to change our network's configuration, and then we can deploy a contract like that. So what I'm going to do here is I'm going to pause for a moment. If anyone has any questions, maybe if you guys could ask them in the Discord channel, and I can address them like right away up here. If you have like a question that is like more, global in nature and you want to ask it now, and that way I can just sort of like answer it up here. If anyone has any particular questions, happy to answer them, because otherwise people don't hear the questions from the other rooms. Happy to take them. But I'll give you guys a second to do that. And then in the meantime, what we'll do is we'll set up for the capture the flag. So the capture the flag is going to require the same skills that you guys just learned about here just this moment ago. I'm going to go ahead and pass it over to you guys on this one. So the goal of the capture the flag, and I can bring the slides back up over here. I'm going to give you guys a hint. So the capture the flag, this is the first one. It's going to be it's 2:45 now, so we're actually going to go a little bit later with this one. We're going to go until 3:15. So we'll take the next half an hour to do this capture the flag. Your goal is to get the flag minted. And remember that the message sender and transaction origin are Solidity globals. So if you see those, make sure to check the Solidity docs to understand what they are. I'm going to send over to you guys in just a moment the address for the flag. And so that way you all get started at the exact same time. So I'm going to send that over the announcements channel. So in case you guys see it, I'm just going to go do an everyone and ping you all here. Hey, everyone. And I'm going to take this off the live stream to drop the address so nobody gets a head start. And I'll tell you guys exactly when I'm going to do it. So let me go ahead and just pull off the live stream. And I'll send you guys over the address here. Okay. All right, so I'm going to send over to you guys this flag here. So once you guys are ready, the key thing here is I'm going to send it to you on Optimistic Kovan. This one's going to be a mixture of a challenge of just getting your hard hat environment ready and being able to deploy a contract quickly, and also being able to understand the challenge. So I'm going to send you guys over this link. And once you go to this link, what you're going to see is the contract is already verified. So you can, as soon as you get the link, you can go right at it and be able to start to attack the challenge with your team. So I'll go ahead and post it in 5, 4, 3, 2, 1. There's the flag. Your goal is to mint that flag. So I'll take a look at who's the first one to mint it. The first team to mint it gets 5 points. Second team gets 3. Third team gets 1, and good luck, everybody. Call us around if you have any questions getting hard hat set up, and we want to help you guys out on this one, so let us know.
mirror on the wall. Money, move me along. Heart in the air. Baby, I don't care. I think about it too much now. I think I try too hard to figure it out. I didn't know what I was on about. I think I finally got it figured out. Mirror, mirror on the wall. Money, move me along. Heart in the air. Baby, I don't care. Mirror, mirror on the wall. Money, move me along. Heart in the air. Baby, I don't care. I think about it too much now. I think I finally got it figured out. Mirror.
I feel it tempts me, and my heart is empty. So stand in front of the people who remember who you are. The opposite of me, the tide was changing, it pulled me out too far. Over it, all I know. I kicked it to the ground and I'm running. I've been listening close to a broken phone. If it ever rings, I won't even know how to make the words out. If only it wasn't true, but I know you're over it. All I know. I never wanna have to ask the questions. I kicked it to the ground and I'm running. I never wanna have to ask myself. I've been listening close to a broken phone. If it ever rings, I won't even know how to make the words out. wait for love.
I didn't know what I was on about. I think I'm finally getting over the drought. I start to ramble and I open my mouth. I think I finally got it figured out. He wants to know me, he opens his mouth. I think about it every then and now. I didn't know what I was on about. I think I finally got it figured out. Mirror, mirror on the wall. Money, move me along. Heart in the air. Baby, I don't care. I think about it too much now. I think I try too hard to figure it out. I didn't know what I was on about. I think I finally got it figured out. Mirror, mirror on the wall. Money, move me along. Heart in the air. Baby, I don't care. Mirror, mirror on the wall. Money, move me along. Heart in the air. Baby, I don't care. I think about it too much now. I think I finally got it figured out. Mirror.
Okay, everybody. So after one round of Capture the Flag, we have Team Coffee in the lead with 5 points, Team Unicorn in second with 3 points, and Team Mushroom with 1 point. That is our current standings. Way to go, everybody who completed that. I saw that 9 out of 10 people, 9 out of 10 teams completed that, so you all got it. I mean, if we look at the flag here, we could see who all of the NFT holders are now, right? So we could go over to this yellow flag, and we could click into the token tracker, and we could see that there were 9 people, or there was 9 holders with 17 transfers. So way to go, everybody. Yeah, awesome work on that. Really impressed. I mean, that was a tough one to start off with. So really, really great work. Maybe what we could do right now is go over how to be able to do something like this. I'm curious how Team Coffee did it, because they did it like the moment after I completed it. And some people in this room are wondering exactly what they did. So Team Coffee, we're calling you out over there. We'll be watching closely on the next round. No, just kidding. You guys did an awesome job. All right, so we will go ahead and just kind of jump into what we're doing over here and take a look at how we could have solved this problem. So when I drop the NFT, right, or when I drop the address over here, what you could see on Optimistic Covan is, not this announcements, but this one. If we go out here, we see, and I think everybody that I talked to understood kind of like what this was getting at, right? Which is great because you guys are starting to get the concepts that we talked about earlier today. So require message sender is not equal to transaction origin, right? So how do we think about this? What we need to do in order to capture this flag is we need to call this capture function, but we need to call this capture function at a time when the message sender is not equal to the transaction origin. How could we possibly do that? We know based on like the slides that we saw earlier today that if we just call the contract directly, the message sender and transaction origin are the same, right? Because the message sender is going to be the person who most recently called the function, and transaction origin is going to be that original EOA who kicked off the transaction at the very beginning, right? So in order for us to be able to pass this test, what we actually need is some sort of like a, I don't want to say intermediary, right? But like something in between, right? We need like a contract to sit in between the EOA calling the capture contract. So that way the message sender would be the contract calling the contract and the transaction origin would still be that EOA, right? So what you had to do was you had to deploy a contract and deploy a contract which called this contract. That's pretty tricky. So great job to everybody who got that. I'm going to go ahead and just show how I might approach this problem. Maybe taking it from scratch. I mean, we do have a greeter over here, which I might as well make use of, so I don't have to like reinstall everything, right? But a couple of people asked me like maybe how I'd approach this. And essentially what we want to do, right, is we want to deploy a new contract that calls this contract over here. So the first thing that we need to do is think about what that contract looks like, right? So what does that contract look like? Our contract could look something like this, where what we're going to do is we're going to call this capture function. And realistically, we could probably do this on constructor if we really wanted to, so that way we didn't have to like call this contract. So on constructor, we could call capture. And so as long as we deploy this contract, right, we won't be the message sender, but we will be the transaction origin, and it's going to mint the flag to us, the transaction origin, right? So by deploying this contract, we would be able to do it. Now, the tricky part here is this capture function needs to interact with this contract over here, right? So I have this contract's address, and we will take that address over here. We can hard code it, right? So maybe we'll say like this is the challenge, and we'll hard code this over here. And then what we want to do is we want to call this contract and call capture on it. Now, we learned a couple different ways of doing this today, right? Still, the easiest way I think to do it is to define the method itself on like an interface or a contract and say that we have like an interface to our challenge, and the challenge has some method on it that's going to be called capture, and that function is going to be external. It's not going to take any arguments, right? So that's basically all we have to do here. And then we could say that this address right here is a type of challenge. And we'll go ahead and say capture on it, right? And so this should kick off the process that should mint us the flag. You guys did this super quickly, and I'm super impressed. So what we could do from here is we could go ahead and deploy this contract. Whoop, maybe that's not inside of a, there we go. What we could go ahead and do now is we could go ahead and deploy this contract and go ahead and mint us that flag, right? So I think I still have in here an account that should still have some Kovan Ether, unless somebody took that. But we can go ahead and try to see if I can deploy this greeter now. Is it called greeter? No, it's called contract. So let's go ahead and deploy this contract. I take no constructor arguments, right? And then we're going to have this contract. It's going to be deployed. And on deployment, we should mint ourselves a flag, right? So let's go ahead and see if I can do this. So again, it's scripts deploy, and we're going to deploy into optimistic Kovan. I don't know. Whenever I put my private key up on a live stream, somebody takes the ether out. So I don't know if somebody did it this time. Let's see. Somebody usually does it. Let's see. Test stream, does it still have an... Oh, look at that. You guys are nicer than most people. Most of the time, somebody screenshots my private key. Okay, I deployed the contract, and we have it out there. And so that should have minted me the flag, right? So like we can kind of test that out. My contract, or my address is going to be 683. So if we go back to this this flag, we can go see if I'm a holder. We can go see when the transactions occurred by taking a look at this events tab. This is where I found the leaderboard. So we found like who was able to complete this quickest, because we have these transfers that are emitted by the NFT that tell us which addresses minted the flag, right? So most recently we had one 25 seconds ago by 849, but do I have one from me? That's the key question. I have one from 683. 683. There we go. There's me. So I came in 44 seconds ago, right? And was able to deploy it. So the key thing there, making the transaction origin not the message sender, was we had to deploy a contract that then talked to the other contract, right? That's really key in terms of context. It kind of went over a little bit of call data, right? Because we're making that call to the other contract and all of the hard hat stuff that we talked about. So you guys pulled that all together and was able to do this. I'm really impressed. So great work on all of that. What we're going to do now is we're going to take a break. Let's make this one a 20-minute break because we're kind of pushing up on time. So we'll come back at 3:45. And from there, Al is going to take us on some talking about unit testing, a little bit more about hard hat. And if we have time, we'll kick off the second Capture the Flag tonight. If not, we'll kick it off starting tomorrow. So we'll take a break now and we'll come back in 20 minutes. So I'll see you guys in 20. Yep.
Save me from a blue screen, make me up a new scene, spinning like a beach ball, endlessly, following all my instincts all the time, but it betrays me, says I'm doing fine. Acting on a green screen, I just wanna be seen. Peering through the fog is all I see. Cooking on a low flame, patience in the slow lane, moving on the map. On a low flame, on a low flame, burning. On a low flame, on a low flame, on a low flame, burning. On a low flame. On a low flame, on a low flame, burning. On a low flame, on a low flame, burning. You set my heart on fire like a ghost. You're a ghost. You said I'm a liar. I don't know. I don't know.
We're gonna log this. Okay. just
It's
called a contract
late
directly, the
September.
message sender and
I
transaction
can
origin
feel
interact with this
what
contract
you
over here,
feel.
right? So I have this contract address.
I would write you a letter just to say that you missed it.
It's easy, easy, baby. I'm easy. 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 Easy, easy.
face lost track of the time. I didn't notice, is that just the way it goes? Who knows? All of the smoke from the fire burned our eyes, and some days I think it still does. We were too young to be tired, and the real world was somewhere else, leaving us behind.
Test, test. Oh, okay, we're on. I'm not sure if I'm on the stream yet. Okay, cool. Thank you. Hey, everyone. We're going to do a module on unit testing. I will just, and I'll introduce myself real quick since it's my first time up here. My name is Al. I'm one of the instructors at ChainShot. And to echo Dan, I've been hanging around in the kind of side rooms, and I'm really, really impressed by what people have been able to do in such a short amount of time. Some folks have never even written Solidity, and they deeply understand like context and how message sender changes with how you hit a contract. So that's really impressive. That takes a lot of time. So everyone here who has really sunk their teeth into the content, congrats, really impressive. So we'll do unit testing. I'll cover just kind of the basics of it. We want to, after this like short module, be able to write up simple tests to test our smart contracts, because that's the most important thing. And then after we do this unit testing module, we'll have another activity for you guys, very similar to Capture the Flag. Basically, we call them the hard hat games. They're basically smart contract puzzles. They're really fun and much more accessible, in my opinion. Like they're as challenging, but just, you know, really accessible all around. So cool, let's get into it. So what we're gonna do today is set up a smart contract that functions as a faucet. Most of us here today have interacted with a faucet, or you may already have. So a faucet will be very simple. Our smart contract will be able to be hittable by anyone, and people will be able to withdraw a certain amount of ETH from that faucet, just like in the picture, and receive some ETH, right? So what do we want out of the basic functionality of this smart contract? Addresses, as I said, addresses should be able to withdraw a certain amount of ETH. And as a question that we ask ourselves as we're designing the smart contract out is, do we want to set up any filters or limitations? Like, should we just allow anyone and everyone to hit this withdraw function 1,000 times and potentially drain the contract? Or maybe we'll set up like a minimal Sybil resistance so that people can't really do that, and we'll look into how we're going to accomplish that. And we're going to develop this contract in what I call an inverse TDD approach, an inverse test-driven development approach. So we'll set up the contract entirely first, then think of test cases to kind of secure it. And so if you guys want to follow along, this should be pretty simple. You guys should be able to just create a new hard hat repo. So I know you guys are working with like a bunch of hard hat repos today. If you guys just do a new terminal, just go ahead and do npx hard hat, create basic sample project, and you'll be right where I am. So as an intro to testing, let me see. So first I'll cover inverse test-driven development as a smart contract formula. So first, we lay out our contract fully, which we will do in just a second. And before deployment, way before anything in the test nets or in the mainnet, we write each of the expected behaviors that we want from the contract, all of the assumptions that we're making in the contract, and any corner cases we might think of. Some questions that fall into this is, what access am I giving and to whom? And especially the critical functions, for example, in the case of a simple faucet, the withdraw, right? It handles Ethereum, it handles Ether, sorry. So it is considered a critical function. We'll also pepper in some cool functions like self-destruct, which I saw some folks today were interacting with, but weren't fully sure what self-destruct does. One of my favorite opcodes for Ethereum. So we'll have a faucet that we'll use, and then we'll destruct it. So also a critical function. Who can call that self-destruct on that faucet? Because as a note, when you destruct the contract, whoever you designate to, the self-destruct opcode takes an address as an argument. And what that argument is who to give the ether in the contract that was destroyed. The ether in the contract that we destroyed does not get destroyed. It gets routed somewhere. So as more questions, how and when should people be able to call functions, and the logic flow. So like after X happens, we want Y to happen, right? And we can test that out. So we do each of these testings in what are called it blocks. So we'll jump into it shortly. is this. Okay, so let's actually get the faucet up and running. So what you'll notice is in this basic sample repo, we get the contract greeter. You guys probably are very familiar with it. So what we're going to do is, let me open a terminal. Apologies if I'm a little slow. This is not my laptop. So let's see. Nope. Okay. So I'm just going to not do the terminal and just do the VS Code terminal, if I can. Where is this? Should I do escape? Let's see. Just standing around the computer guy. Let's see. Maybe here? No? Here? Okay. Terminal? No. Yeah? And what? And I'm looking for the top bar. I'm not sure. So I'm looking at the camera people. Like if I disconnect this little top bar with the view terminal should do it. Or Option shift and what? Option shift and no, it's not giving to me that. Sorry. Yeah, Dan, sorry. Foreign device and the little pop-up, the menu is not appearing, and couldn't find the terminal path to here.
What are you trying to do?
Get the terminal. So if you go to the terminal.
Oh yeah.
And I guess you already opened it in the VS Code.
What do you need? Oh yeah. You just need one of them.
Okay. Yeah.
Good.
Just perfect. Down the man. Thank you. Yeah. Okay. The dangers of using other devices for presentations. Cool. So you have your basic hard hat repo. It's set up with the greeter.sol. It's set up also. You guys already saw this with like sample scripts and sample tests. So today we're going to take a look at the test folder. I'm going to kind of close this a little bit. So it sets you up with a very simple tests that you can just see. So it actually goes ahead and deploys the greeter contract for you on the local hard hat network. And then it deploys it, as you can see, the greeter.sol at constructor time. It takes a string greeting and it sets that whatever that greeting was passed in as the greeting in the state variable of the contract. So here in the sample test, you can see how it's a really kind of simple preliminary obvious test. So it's deploying the greeter contract with the string hello world, and then it's testing that the state variable via the greet public access is equal to hello world. So it's even testing the set greeting function on the greeter. Let's kind of do away with this and do a quick test just to see the syntax of running tests. So I'll change this up and I'll deploy this with hello world, and then I'll do a test to make sure that that's equal to something. So this test we should expect it to fail. So let's see. I will go to the terminal and do npx hardhat. npx hardhat test, sorry. So we're testing the greeter, and again, it actually says here assertion error. We expected hello world, but we got something. So let's fix that into hello world. And I do this kind of obvious one first just to make sure that we get familiarized with npx hardhat test. So I'll do that command again. And there we go. We're all good, right? We're getting the behavior that we're expecting. So let's do away with the greeter.sol. I actually won't even do anything to it. I'll just do a new contract, a new file in the contracts folder, and I'll call it faucet. Back to like what we're actually going to do. And I'm glad I didn't delete it because I always just copy paste this boilerplate stuff, the license and the pragma, and then just call it. So we'll write this out slowly but surely, contract faucet, and at constructor time, maybe we'll do it at constructor payable. And just to get some logic down on there, the important part of this presentation is the testing of the contract. So we'll just write it out real quick, and just to get some factors in there that we can actually test this, maybe we'll do a state variable that we'll store the owner in, and at deployment time, we'll do owner equals message.sender, right? So whoever deploys this contract is the owner of the faucet. And that'll give us some cool kind of logic gates to test with. So maybe this is really simple, right? We get a function up there that is withdraw, and maybe it takes a uint amount to withdraw, and we'll make this public, so it's a public faucet, anyone can hit it, and we'll do very simple. So whoever hits this function, transfer that amount to them. So let's see. Cool. All right. So it's going to complain. What is it? So it doesn't error on hover. It's complaining because I'm trying to send Ether to a type address. So if you guys know in Solidity, there's two types for addresses. There's type address that should not be able to kind of receive Ether in most cases, and there's type address payable. So it's complaining here that I'm trying to send some Ether to a type address. So I'm going to typecast it to type address payable by just wrapping it in this payable parentheses, and we'll do this a couple of times throughout the contract. So this is looking pretty good for a simple faucet. And let's go back to the slide, see if we missed out anything in the formula. So cool, like going back to this formula, let's kind of think about the expected behaviors that we want, the assumptions, and the corner cases. So like we want to deploy this faucet with some ETH, so we'll do that shortly. Otherwise, if the faucet does not contain any ETH, and that's a neat note too. So like if we were to deploy this faucet and say, hey, we've got our faucet up and going, but we didn't deploy it with any ETH, it would be basically a dead contract at that point because it doesn't have a function. It doesn't even have a function receive for this contract to accept ETH. So if you deploy it without thinking ahead and deploying it with Ether, because the constructor is payable, so it's able to accept Ether. If you don't do that, then that's a dead contract, and you'll have to redeploy again. And there's also the inverse cases where you deploy with a ton of Ether, and you don't account for cases where you want to withdraw that Ether. So that's both a dead contract and dead Ether, which is a very unfortunate case. So cool. This is what we'll lay down logic-wise. I think I missed a few. So number 2, contract should set the appropriate owner. And then 3, withdrawals should be reverted if a user attempts greater than 0.1 ETH. So let's get that in there. What we can do logic-wise right here is we can require that the amount passed in is less than or equal to, let's see, this is, so as you guys know, Solidity denominates these Ether values in way. So I'm just going to do a guess that is around 0.1 ETH. We'll do further testing, but for now, we'll just require that the amount isn't something outrageous like 5 Ether, 10 Ether. We're just going to limit it and say like around 0.1 Ether or less than that is, or less than or equal to 0.1 Ether is great. I may be missing a couple zeros, but we'll figure that out. That may be like 0.001 Ether, for example. So cool. Number 4, if we have time, we will whitelist recent withdrawals, which will help us with that like soft Sybil resistance so that someone can't just script the withdraw function and kind of drain the contract entirely. And then again, if we have time, the contract should self-destruct. And if we have time, we'll do some events testing. So I'll just lay down the logic here real quick so that all that is testable. And I'll do a quick destroy function just to talk about that. So I'll do destroy faucet, and we'll do external. And then one cool thing we can do with the owner, now that we've set it at deploy time, is we can actually just permission this very critical and sensitive function to the owner, only to the owner. So we can do require that the message.sender is the owner. Only the owner can destroy the faucet. And then self-destruct is pretty simple. You just have to do self-destruct and pass in an address where you want to send any Ether potentially in the contract that you're destroying. And we'll just do owner. And it's going to complain possibly because it's going to want me to typecast it to an address payable because owner is declared at the top as just an address. I could have also done address payable, and it accomplishes the exact same thing. So cool. We've got a very simple faucet up and going. We can withdraw from the faucet at limited amounts, and we can destroy the faucet. So let's see. I'm trying to make sure I don't miss anything. Okay, that's pretty good. We'll get the test up and going, and if anything, this is hard hat, right? So it'll allow us to edit anything on the spot. So what I like to do usually is, again, this is the inverse test-driven design or approach. We have our contract that we want to test. Cool. We've kind of thought of the assumptions, all the corner cases, sure, very simple ones. And I will go to this sample test file. And what I usually like to do is just like literally convert all the greeter references into whatever I want to test. This is just a habit that I've fallen into. So I'll just, anything that I see for greeter, I will just change to faucet. I know there's quicker ways of doing this. So let's see, faucet, faucet, faucet. So it'll look for the faucet contract that we just wrote. And cool, I think we're good to go. So the cool thing about just doing that quick replacement is you're set up kind of instantly with all you need. You're set up in your tests with a very simple test here that deploys your faucet for you. So once it's deployed, you're actually able to call the functions and perform the testing. So let's see, I did want to describe just a couple things before we fully get into it, just back on the slide. The libraries that you see also included in the sample test is like, it requires chai. And as you saw previously, all these tests will be written in JavaScript, which Hard Hat allows you to do quite easily. Chai.js gives us access to the super useful functions that we'll use, like assert and expect. So they make testing super easy and logical because you can just do like assert that this equals that and expect this behavior from this call, stuff like that. So Hard Hat should already have installed chai for you because you clicked basic sample project, but if not, just run npm install chai. And then last thing for the slides, you'll notice in the tests that it contains like a bit of I wouldn't say funky, but it's just like it's kind of newer syntax. It's JavaScripty. It has like this big describe block, and then inside it has an it block. So I always like to kind of cover these first. The best way to think of that describe block is just that it's a general function scope that describes the suite of test cases enumerated by the it functions inside. So we'll see like here, we're just describing a faucet and we can name it anything like faucet general testing, right? And inside we should have faucet general testing specific its. So to cover just the it, inside that describe, we have an it function. These are your specific unit test targets. So just sound it out. I want it to X, I want it to Y. So if we look back, as the last time I flipped, I promise. So just sound it out. So if we're looking at this it block, it should return the new greeting once it's changed. This is still referring to the greeter contract that we had initially. So maybe now let's convert this to the faucet. So for one, let's start from the very beginning of the flow, and it should, for example, deploy the faucet with an ether amount. That's something we want to check initially. So you'll notice on line 7, we're actually doing deploy, but this faucet has a constructor that does not take any arguments as the greeter did. So we will actually deploy with an empty argument count, and then the way to deploy or to kind of override the message value in contract calls like this is quite simple. You have to just do open and close curly braces and just do value. And something very useful to cover is Ethers offers you these utils functions that allows you to quite easily code up like ether values. Since the EVM reads them as way, like that's one of the most confusing things to me because I can't think 18 decimals ahead, so I need to use these utils functions. So for example, it has this fantastically useful function called ethers.utils.parse units, and you can pass in just human readable form. So I'll just do deploy this faucet with 10 ether in it. And that's it. So that deployment should now deploy the contract itself and fund it with 10 ether at deploy time. So that's all we need. And then one way to test this would be, for example, again, we'll use ethers to utils. We can do after the faucet is deployed, let's check its balance. So a way to do that is, and I'll just add this real quick here as a variable, we can, hard hat plugs you into the hard hat provider, the hard hat network. So the way to fetch that is just to extract it from the ethers library that we're importing at the top. So the provider is just basically a pointer to the hard hat network that we can make queries to, and we'll be able to do like provider.getBalance of address or provider whatever. So if we want to get the balance of this faucet on this network, we can do await provider.getBalance, and then we'll pass in faucet.address. That's one of my favorite parts of testing. It's actually really simple. You just deploy it, name it a variable, and then you have access to like a bunch of stuff on that variable like .address. So you don't have to do like .getAddress, parentheses, something like that. So we'll get the balance from that, and then this is like the first time we actually lay down some testing. So we can do expect, await, actually, nope, we can do expect balance, so .to .equal, and then we can do, again, ethers.utils.parse units, 10 ether. So there we go. So we query the contract balance after deploying, then we query the provider to say, hey, what's the balance of the contract? Should be 10 ether. So let's run that. If we go back to the terminal here and we do npx hard hat test, let's see. Cool. So there we go. It should deploy the faucet with an ether amount. I should put 10 ether or whatever. So that's a bit more specific. And then I always like to to make sure that I'm not messing up anything or I'm not making any assumptions that I shouldn't. I just test myself or test that the test is written accurately. And I'll do like 11 ether. So it's a wrong test basically. But I just do this to kind of make sure that there's nothing here that's tricking me, and you'll notice it immediately trips out. It's like, hey, no, you don't have 11 ether in there, you have 10. So cool. I'll leave this at 10, and then cool. So we can do more tests. So the cool thing about the it blocks, and this is the flow that I've usually fallen into, is just copy paste the entire it block that you've found is syntactically correct and succeeded, and just lump it into this describe scope, and just again change it to your own needs. So now it should set the owner correctly, and then again we'll do away with all of this. One thing that I will cover is notice that if we're doing a brand new it, we have to redeploy the faucet all over again in this new it, because the faucet that we deployed in this first it block is only available to that scope. So one thing we can do before we get into more tests on and on is we can do a before block. Let's see, before, and then I may need to briefly cheat and look at the syntax, but I think this is right. So the before block, and these are part of the Mocha hooks, which in some of the hard hat resources, which we will link you to later, they're more comprehensive. It describes a lot of the testing libraries that we use, but these are part of the Mocha hooks that you can do stuff like before each, which I know Dan covered briefly. So before is really useful because it will, as always, the logic flow starts from top to bottom. So it will start at describe, just faucet general testing, and hit that before block. And before will run once before all the subsequent it tests. So what do we want to put in there? The faucet deployment, so that we don't have to redeploy a faucet every time we want to test it. So we can do all of this in the faucet, in the before block, and there we go. So one thing to watch out for is so this will deploy the faucet before the tests and help us clean the tests up, right? Because now we can erase these, but we are still accessing these variables. So one thing to look out for is, like, for example, in the describe scope, which is the global one, we want to declare that faucet variable and then just initialize it with a value in the before block. So now we have access to the faucet and we're all happy. And our tests are much cleaner. So, and for example, since I know I'm going to use provider again, I'll just put that in the global scope so I don't have to redeclare it every time. And there we go. So now our tests are kind of really clean and neat, and I'll do a little space. And cool. So for setting the owner correctly, this one's quite simple, but it covers some good functions that you may have not seen already. So the way we want to test is, remember, this deployment was done by the default hard hat connected account. So by the first signer, if you guys have kind of cut up with that, hard hat will run any scripts and tests for you with the account number 0 of the hard hat network, which is pre-funded with like 1,000 ETH each or 10,000 ETH each or something like that. So what we need to do is actually fetch the address of that first account that deployed and make sure that that's the address that is initialized in the faucet. So we can do, and we'll destructure it or receive one argument out of it, and it's await provider.list accounts is the method. What list accounts does is it gives you back a whole array of all the network addresses on your network, on the hard hat network. So I can actually do so right now. For example, I'm just gonna show what it sends back and just do console.log addresses, like all the addresses. We're not doing anything in the test, and I'll do npx hard hat run, and let's see, what does it mat at? It's saying await is only valid in async functions. I saw Dan run into this a bit earlier, so I think it wants me to just label this as asynchronous since we're using await here, and then it should be happy. Let's see. Cool. So there we go. Notice we console logged. It'll actually give you the first, I think that's 10 or 15 or whatever. First few addresses of the hard hat network. These are all funded. And the one we're interested in is this signer 1, right? The signer 0, technically, since everything is 0 index in computer science, or most things are. And that's the address that should be the owner of the faucet, because that's the address that paid for the deployment and was set up in the deployment. So cool. The reason I wanted to show that was to show all those addresses was we can destructure them by order and just do let address 1. We can actually do let address 2, let address 3, and you'll get back the first 3 and assign them into those variables. So for one, we're just interested in that address 1. And what we can do now is simple tests. Back to expect, and we can do await and make a call to the faucet and await faucet.owner. So a couple folks were asking about this earlier, actually. So when you have a smart contract and you have a public state variable, Solidity is cool enough to basically create a getter function for that variable. So basically, Solidity does this for you when you declare a public variable. So we can actually just access it directly and do await faucet.owner, and we can do .to.equal and .equal address 1, right? So cool. And let's see if it likes that. It should. Cool, there we go. And again, as always, I just like to test against myself, make sure I'm writing that, because sometimes it's happened to many times that all your tests pass and it's looking great and that's awesome, but then it's because like you're testing against the wrong file or something. So now we can test that some other address is the owner, and this should fail. So let's see. There we go. Instantly fails, right? It's like, hey, no. So cool. We'll leave that as address 1, and we'll get a couple more tests up. Let's see. So it's looking pretty good. And again, for the next test, just copy paste your last successful if block, get it in there. And let's see, what else did we want to do? I'm just going to check this formula that I wanted. Contract should set the appropriate owner. Contract should be deployed with some ETH. Otherwise, it wouldn't be a good faucet, sure. And withdrawals should be reverted if a user attempts greater than 0.1 ETH at a time. So, all right, let's see. So let's test the withdraw function. We want to make sure that people don't overdraw. So that's the last one. Okay, so it should revert if overdraw is attempted. I'm not even sure if that's the right term. So should revert if overdraw is attempted, and we can do away with all of this. And we can do, for one, we want to, first of all, declare a variable for the withdraw amount. So this is a bit cleaner. And we'll use this, this ethers.utils.parse units, and we'll do 0.1 ether. How cool is that? You can actually do decimals and just say, boom. And withdraw amount now holds the amount that we want to withdraw. And simple tests. We want to expect, and then we can do await faucet.withdraw and pass in the withdraw amount. So let's see, should revert if overdraw is attempted. So this is a valid one. So I'll actually do 8 ether. So this user will attempt to withdraw 8 ether from the faucet, something like obviously outrageously high for what we've stipulated is allowed. And we can do, this is the cool thing about the libraries that we're using. So notice mainly we've been using like .to equal, but it also has something really cool, which is .to be reverted. So you can expect failure as part of your tests. So cool, let's test that out. NPX hard hat test. Let's see. Transaction reverted without a reason. Let's see. It should revert faucet.withdraw amount. So let's see. What is it? Did I maybe not do enough? So I'll do like a small amount. So that should be like very small. And what am I looking at? Let me close this one. Nope. And let's see. It should revert if overdraw is attempted. We're doing a withdraw amount of 8 ether, which is like a bunch. And we're doing await faucet.withdraw, withdraw the amount, and it should be reverted. Okay. I see. I think I see why. Sometimes, so these libraries are really cool, but they are a bit finicky because sometimes you have to await outside because like this .to be reverted is a special function. So I think you have to await the whole statement as a whole. So let's see if it was that. Hope it was. So cool. Sometimes it's really silly like that. Okay. There we go. So should revert if overdraw is attempted. Someone tried to withdraw 8 ETH and no good. Perfect. So we tested, basically this test from 26 to 29 basically tested that this line works. And if we take this out, the test will fail because there's nothing that will make the function revert, so the test expects a revert. So cool. And then let's see, back to the formula real quick. Do we have time? Yeah, we do, I think. Cool. So let's do the self-destruct one since we already did that logic. So again, I'll just copy paste the it block. I don't know if you guys can hear me okay. And it block, and we can do, it should destroy, and only the owner should be able to do so. Kind of a long name. And then let's see, we can do this one should be pretty simple. So we can do let value. So we'll do let value, and then we'll do provider dot. And the way to check if a contract or if an account is like a contract or an EOA, is you can do provider.getCode, which will basically say, hey, Ethereum address, do you have any code associated with you? And what that get code does is it brings you, it returns back the bytes value of the smart contract code in bytes, right? If it returns 0x, then either that smart contract does not have any code logic or does not exist, or it's an EOA. Most of the times, it's an EOA. So we'll do let value equals await provider.getCode, and we will await that. Let's see. No, we don't need this outside await now because I don't think we're going to use anything too extra, and we can just copy paste one of these back into here. And we can do await faucet. Once you call destroy faucet, and again, this is still linked to the default signer, right? So, this owner check that we have here protecting the faucet should pass adequately because we're calling it from the owner. So await faucet.destroy. And you know what? I probably should have done this first. So I'm actually going to structure it this way. I'm going to say await faucet.destroy. Faucet, and that's it. So I'll start the test off by making that call. So that kind of goes into that logic flow testing, like if X happens, then Y should be the case, right? So as soon as the test starts, let's destroy the faucet. Now we're getting a value by pinging the provider and saying, what's the code at the faucet address? Does there still exist code logic there? Is there still something stored, or is it 0? So we'll be able to check that and do expect value dot to equal, and it should equal 0x because when a contract 0x, right? When a contract self-destructs, it just kind of zeroizes the value. So let's look at how that's looking. And there we go. Should destroy, and only the owner should be able to do that. One cool thing is, let's say we want to test against the assumption that the owner is always rigged up by default, right? Because we're working with that assumption all throughout these tests. So one thing we can do is we're going to get another signer. So notice on line 22, we're actually getting a bunch of addresses back. Now we need a signer because we need someone to sign the transaction to pay gas that isn't the owner. And the way to do that is just, you can do let signer equals await provider, and this is saying like, hey, Hard Hat Network, get me one of your default signers. And this one will not give you back a bunch of addresses like the other one. You can just specify which one you want. So I'll just do get me signer 5. Like out of all those addresses that you funded, get me one of those signers. And what we can do is before we destroy, we can actually do this. So await faucet.connect, and we're going to connect to, I'm actually going to call this signer 5, and we're going to connect to signer 5. And this is really cool. So this faucet.connect signer, it gives you this whole new instance that you can use to make calls to the faucet via the signer 5. So pretty cool. Now, this should fail as a test because the value at that point should not be 0x. It should still be a full string representation of the code inside, because the self-destruct should not have gone through. Signer 5 is not the owner, so it should have reverted. So let's see how that looks. Let's see. And there we go. So transaction reverted without a string. The reason is it hit this require, and it's saying, hey, no, you're not the owner, so I'm going to revert your transaction. So cool. It's looking good. And then I think maybe I have time for one more. I always like that kind of like low-key Sybil resistance. You guys aren't too familiar with Sybil resistance. It's basically, how do we make it so that a bot doesn't just script this, or like a human just doesn't kind of tap it like crazy and drain the faucet. So there's many outside protocols that attempt to solve this really difficult issue, like Proof of Humanity, which gives you like this whole registry of unique humans tied to addresses, and that gives you a whole lot of of logic power to structure contracts. But for now, we'll do like a soft civil resistance by doing a mapping. So a mapping is basically like a hash table. If you guys have, that CS or Java background, it's basically just a hash table that hashes a key to a value, and we can do a mapping that hashes an address to a bool. And we'll do public, and we can name this mapping has withdrawn. So this will allow us to keep record of people that have hit the withdraw function, and we can, I'm glad I had time to show this one because this actually allows you to stack requires. So first of all, let's do when someone withdraws, require that their amount is less than this amount, and then transfer that amount to them from the faucet. All good. And then at that point, we can toggle the has withdrawn at message.sender to true. And that will store that address and say this message.sender has withdrawn. Because when we initiated this mapping, the has withdrawn, it defaults all the values to false, to falsy values. So, and now, when someone attempts to hit the require, we can stack require conditions. So we can stack 10 of these requires if needed. And we can do require that the has withdrawn for this user is false. So require that this user has not withdrawn before if they have revert. So it's kind of like, I always say it's like a soft civil resistance because it won't really accomplish much. People can still script this quite easily, but I mean, it gives them a harder time because they need to spread out Ether over a bunch of accounts. Like say if they want to run withdraw 100 times, which will not get them too much Ether, right? Because we're limiting the withdraw amount by quite a lot. But it gives them that extra barrier of them having to fund 100 accounts or more with private keys and using those private keys to script them. And it's just kind of a nice little barrier for that. So we'll do a final test to make sure that this has withdrawn works. So we can do one more at the bottom, remove these spaces, make it a little cleaner, and I'll just copy paste the last it. And we can just do should not allow a double withdrawal. So let's see. Let's use signer 5. We'll just keep signer 5 here, and we'll do withdraw. And I'm going to get the withdraw amount that I had up here. Let's see, where is this? There we go. I can just do this like as a, oops, nope. As a global thing. And then there we go. So I can just do let withdraw amount. Did I do that in the least efficient way? Okay. So I'll just do, okay, there we go. So withdraw amount equals that. You know what? I think I had it right. There we go. So, and then I just do away with this one. Cool. So should not allow a double withdrawal. So we'll do withdraw and then withdraw amount. And so signer 5 withdraws one time, which should toggle them on the has withdrawn mapping to true. And then we should expect, I'm just going to copy paste this to be reverted again, just so I don't have to like type it out all again. And we can expect that the faucet.connect to the signer 5.withdraw to be reverted, because at that point they're doing a double withdraw and that's not allowed. So cool. All right, so let's run that. Should not allow a double withdrawal. Transaction reverted without a string. I think it's also still mad at the last one that I set up without fixing. So let me do that real quick. So I will remove this connect just from the last test so that the destroy faucet function is called by the default signer, which is the OG owner. And so that should fix that first big error message. And then let's see here, it should not allow a double withdrawal. So expect faucet.connect.withdraw amount to, oh, you know why? Whoops. I had a withdraw amount for the overdraw. So I'll just do withdraw amount overdraw and then withdraw amount, appropriate, and that's the worst variable names. And now this should work. So he's going to draw the appropriate amounts each time, but he can't do so more than once in the lifetime of the contract, at least according to just how we were laying the logic down. Let's see. Withdraw amount is not defined. Whoops. Did I not save? Withdraw amount appropriate, withdraw amount appropriate. Oh, withdraw amount, what was it? I'll just do this. All right, that should do it. Oh no. Change the amount? Okay. Oh yeah, true. Thank you. Yeah, good call. And I'll do 0.0001 ether, a very small amount. And I think you're completely right. No, okay. Should not allow a double withdrawal. Does it want like a smaller amount? That should be like super small. I'm not even sure if Ether's parse utils is gonna like that. Oh no. Let's see, maybe I'll actually just copy paste this directly and do withdraw amount appropriate, and I'll do less than that, and I'll do way, because parse unit's pretty cool. It lets you just specify whatever Ether unit you want. So let's see. Oh no, so it's maybe something wrong in the test. Let's see. Yeah, thank you. Yeah, okay, perfect. I appreciate you calling that out. So someone in my room just pointed out that, remember, this is a logical flow that flows from top to bottom. So at this point, we're working with a destroyed contract, so nothing's going to work. So I'm just going to put that destroy contract test after. So thank you, appreciate that very much. And then, so at the end of all our testing, let's go ahead and destroy the contract. So, all right, let's see. And there we go. Thank you very much. Cool. That's 5 tests. That's inverse test-driven development. So one thing to present is, and if you guys have any questions after this, I'm very happy to answer. Testing is really fun. So before I present the next thing, let's see. So no, this is an outdated. So we have the hard hat games, and sorry if the timing isn't updated, because we're a bit ahead of that. So the next activity, the contract puzzles that I had mentioned at the beginning, is the hard hat games. So those are available in your ChainShot dashboard. So let's see, I'll just pull it up real quick in the ChainShot Web3 EXP dashboard. So let's see. Dan is not enrolled, so let's see. I think I can kind of remember the URL. So it's like article, and it's like contract testing. Maybe, hopefully. So going to bring up, let's see. Article, contract, testing, _ testing. Maybe that one. I like that one. In the Discord. Cool. Thank you. Okay, so pull it up on Discord. And cool. Okay, thank you, Dan. So the activity you guys have linked in your ChainShot Web3 EXP dashboard is basically, it's going to have you clone down this repo to your hard hat local. This is a hard hat repo already. It's just going to have you clone it down to your repo. And what you need to do is a couple of things. There's a couple of flows involved. So one, you get 4 smart contracts involved here. And the purpose of these hard hat games is that you need to set up some scripts to trigger a win function in them. So for example, this first one, really simple, just to get up and running. You have a contract called Game 1, and the purpose of these hard hat games is to have the winner event be emitted. So before you start each game, you have to take a look at the contract, figure out the logic flow that you need to accomplish that. Then when you have an idea, you go to the scripts folder, And so this is all in the instructions, by the way, but you have to deploy each of these contracts. So you have to deploy them first. So as is done here, you have a deploy script that passes in the game1 artifact, then you get the game address. The cool thing is these should be already verified, so you can just see the contract logic, but the contract is on your local. So you should be able to test against that. So you deploy the contract game first because you need a deployed address to test against, and then you go to the win.js, and this is the script that you have to manipulate in order to get that deployed contract to trigger or to emit that winner condition, that winner event. So one thing to look out here is you need to copy paste the address of the smart contract that you want to interact with. So if game one you've solved, which is a really easy solve, and you deploy game two, remember copy paste the game two deployed address here. Another thing very similar to that is edit the artifact that Hard Hat pulls in for you. So if it's game two, if it's game three, and so on. So remember, edit it. So before you tackle each game, deploy the contract first, change the values necessary in the win.js, then think of the logic. So for example, if we're trying to solve game one, as a, it's a pretty spoiled one already, all we need to do is basically anyone calls the win function and you emit the winner event. And at that point, you can just move on. So these are just challenges, nice little challenges that you can do. So in the scripts, you deploy the game one and then go to win.js, copy paste the game one address, game one artifact already good. And there you go. I think it already has a winner in the script. So you can just run this and it'll emit the winner event on game one. And sweet, you're all done. So now you move on to contracts and game two, and notice this game two will have different logic conditions that you need to trigger in order for the winner event to be emitted. So please let us know if any questions. Please let me know if any questions on testing, and good luck with the Hard Hat games. Thanks, guys.
It's time to sleep, it's put to bed, it's punching numbers in my head, it carries on, you wanted to, I'm riding home, still I adore you. I was born with you.